Hey guys, next up we have a talk by Zach Hatfield-Dodds. Zach has recorded his talk already, and he's going to stick around to answer your questions on the live stream as well as the Discord channels if you have. So let me just go ahead and play it in his talk.
This is a picture of Canberra. All right. Hello, everyone. My name is Zach Hatfield-Dodds, and this is my talk, Stop Writing Tests. I am a little provocative with the title, but I want to say up front, I'm also quite serious. When I'm talking about these techniques, it's not that I want you to never write a test again, but I do want you to stop writing tests and think a little bit more about how you're doing that. But first, I kind of need to start with an Australian tradition that we call an acknowledgement of country. This is a picture of Canberra, where I live, and I'm currently doing my PhD in computer science. But before it was Canberra, it was Ngunnawal country, the Indigenous people of the Canberra region who have been here for something like 60,000 years, living here, studying here, working here, playing here. And they named the place Canberra, which means meeting place. And so before I get started with my talk, I wanted to pay my respects to their elders, past and present, and emerging leaders. So I'm talking about testing. And what do I mean when I say testing? It's that activity that most of us do where we try to run our code in order to find bugs in it, or just to check for regressions. When we're running our tests, we don't always want to find new bugs. We might just want to merge a feature in. And so the things that we do as part of testing are like we choose inputs to run on, we run our code, we check that it did the right thing with an assert statement, and then we repeat that however often we need to. It's important to note that this doesn't cover all the techniques that are useful for checking for bugs in our code. For example, using a linter like pylint or flake8, or an auto formatter like black are extremely useful tools. I also really enjoy type checking with something like MyPy. They're great, but they're not in this talk because they're not testing. We're not actually executing our code to see what it does. And I'm going to cover about 3 parts in this talk. In the first, I'm going to talk about why would we generate test cases? Why use these extra tools instead of just doing it by hand? Then I'm going to talk a little bit about what kind of properties we can test, and then finally about some more advanced stuff I've been working on lately, about how you could fuzz your test suite or even have the test generated for you. And so my contention is that when we say automated testing, what we're actually talking about is still a surprisingly manual process. This picture is of what's called the mechanical Turk, which Amazon now has a service by that name. But back in the 1800s, it was a system where there was this robot, this clockwork automata, which could allegedly play chess. And this was well before the first digital computers, well before transistors or even vacuum tubes. And so it caused a great stir at the time. But of course, it wasn't actually a mechanical chess player. It was a mechanism where the human hidden inside could play chess via this extended arm. And so my argument is that a lot of what we do with testing at the moment is this level of manual. What we do is we write tests entirely by hand, but in a format where we can then rerun them automatically. This is certainly valuable. It makes running the tests a second time much, much cheaper and easier, but it's still fundamentally a manual testing process. So let's start to talk about property-based testing. And to do this, I need to show you some examples. And I want to warn you that the examples I show are chosen to fit on a slide. So they're relatively simple and the inputs aren't that complicated. These tools do actually scale to much more complex examples, but in this case, sorry, David, I'm not going to try reversing a list. We're going to try sorting a list. So if we want to sort a list, this is a pretty standard problem to have, but maybe we're concerned that Python's built-in sorted function is too slow. So I've implemented my own faster version of sorted, and we're going to see how we could test it. The traditional way, and this is how I actually always start my testing, is just to try running it by hand. I like to open up Python or IPython and just call it with some inputs. And so we can see that if we try to sort 1, 2, 3, we get the correct result, 1, 2, 3. If we try to sort a list that's not already sorted, 2, 3, 1, we still get the correct result, right? 1, 2, 3, so it must be sorting it. We can then record these as test functions using something like PyTest. So we assert that sorting our list gives us the correct results in both cases, whether the input is sorted or not. And then because we don't want to repeat ourselves, we can actually turn this into a parameterized test, where we list a whole bunch of different examples of inputs and expected results. There's only one problem here, right? The reason my sorted function is so much faster than the built-in one is that it always returns 1, 2, 3. This is great because it is a sorted list. And so if we wanted to test without already knowing the correct answer, which would let us get away from this problem where we have to think up every input and output in advance, we could work out some way of finding a large collection of lists or randomly generated lists and run a test function for all of them where we don't have to specify what the correct answer is. And so this test function checks that our resulting list is sorted, right? We check that for each pair of elements, the earlier element is less than or equal to the later element. The only problem is this would actually pass for my really fast implementation. 1, 2, 3 is sorted. So we would need to add a check that not only is the list sorted, but it's the right sorted list. But it turns out that this test function will pass if and only if I've implemented a correct sorting function. And so a simpler version might have been to assert that sort list of my argument equals sorted of my argument. And if you have a trusted implementation, this works beautifully. But you can often check whether or not your code is correct without knowing how to tell whether the answer is correct. Often being able to detect incorrect answers gives you good tests on its own. And so that's the trick of property-based testing. And I want you to write more property-based tests, and that's what I'm trying to convince you to do. So the second part of the problem is that often the edge cases which cause bugs in our code are precisely the edge cases we don't know about. And this means that it's almost always the exact same test cases that we need to write because we didn't know about them, and so our code is vulnerable, that we don't know about in order to write the test. So what can we do instead? Well, you can use a tool to generate random inputs for you. And I'm going to suggest Hypothesis. Hypothesis is Python's leading library for property-based testing, and it's in fact more popular than most similar libraries in other languages. In fact, the Rust implementation is deliberately inspired by Hypothesis. So let's see what that looks like. Let's imagine that we're testing something that's a little more like realistic code rather than a sorting function. So it's going to deal with stuff on disk, it's going to have some kind of multiple steps of logic. This is the kind of thing that you might actually use every day. And it looks, in this case, a lot like Git. What we want to say is, if we check out a new branch, then the active branch is the new branch that we just checked out. And so this test function says pretty much exactly that. If we create a temporary directory, create a repository, check out new branch, and create it, then the active branch is new branch. But this is kind of a shaggy dog story. Does it matter that we're checking out the thing named new branch specifically? Do we have to have a dash in the middle of the name, for example? And so one simple way to make your test clearer is to move those specific values to function arguments. Because this test now says, if we check out with a branch name, which happens to be new branch, but could be something else, then this should pass. And so that already is a much clearer test to me. And to use Hypothesis, you can now say, instead of making a default argument, let's say hypothesis given the branch name is just new branch. So this is semantically identical. We're not changing what the test does yet. The following stuff happens. But this starts to make it easier to make a more powerful test. If we want to use the branch name in multiple test functions, we can move that out to a helper like this. And then when we start to generalize this, we can say, well, does any Unicode string work as a branch name? And when you go read the Git manual, it turns out that it doesn't. There's a whole bunch of requirements about the length of the name. You can't have white space. You can't have dashes in certain positions. Hosting providers like GitHub or GitLab often impose limits on the length of a branch name. And so we can tell hypothesis that we only want ASCII letters in names and with reasonable bounds. And if we do this, then the test may or may not pass. We might discover a bug. And for example, in this case, if we randomly generate the name master or the name main, it would conflict because that branch already exists by default. And so let's start to revisit the body of the test function. Instead of going through this kind of shaggy dog story, we can imagine going through a similar process. So we generate random repositories as well. We say, assuming that the branch name is not already a branch in that repository, and we check out the branch name, then that branch name should be the active branch. And that's pretty much how I described the test to you in the first place. But now the test is actually checking what I just claimed it does. All right. So what happens if you don't have a set of existing tests that you want to migrate? Do you have to learn the whole hypothesis API? Well, of course you don't. And so I want to show off to you a thing I call the ghost try, which we shipped a few months ago and can save you a lot of time on writing tests. So I'm just going with the same sorting function here, right? And this will be my tests module. So if you have installed hypothesis, you get the little command line thing. And if you look at hypothesis write, then you can see there are a number of things. It can actually write your tests for you. And so we'll go through some of these examples in a minute. But the first thing to do is just go, well, if I write a test for my code, what do I get? And let's pipe that into tests.py so that we get syntax highlighting. And so what we said here is, given an input sequence, which is either a byte string that's binary or list of integers, just call the code. And this is kind of the minimal test, right? We're not checking what the code does. We're just checking that if we call it with inputs, according to the type annotation that's allowed here, then the code doesn't crash. But we could also check some more properties. We could, for example, say that it's idempotent. And that means that calling the test function twice, the second call shouldn't change the input. And sure enough, we get an error. And typoing this, we actually need to tell it the function, not just the module for this. And we can see that if we get the result of calling it, and then we repeat that by calling the same function on the result and the repeat result should be equal. Another test that we could do would be to check whether it's equivalent to the sorted built-in. And so here we go, we get an iterable for this and a separate sequence. So we're actually going to delete that iterable because we want to use the same sequence for each. And then if we run this, we should we discover an insertion error. And so what's happened here is that we don't in fact have the same behavior because sorter doesn't take the reverse flag. But if we fix that up, then we should actually have the same behavior, right? And it looks like we can't pass that as a keyword argument. And so just through this quick process of property-based testing, we've discovered a number of ways in which the function I implemented is actually not the same as the function I was trying to re-implement. But we can look at a couple of other demos as well. So if instead of writing a thing for my particular code, we ask to write tests for the gzip module, for example, and we'll pipe that into our tests file again. We have here a number of different tests. We're checking that we can compress and decompress arbitrary data. We're checking that we can instantiate the gzip file class and so on. And while these tests aren't complete, they'll show you enough of the hypothesis API and write enough of the boilerplate for you that it's pretty easy to finish writing the test. That's all it takes in this case. So once you're using the ghostwriter, the next step, I guess, is to think about, well, what are you going to do to run this? We can, of course, run PyTest on this. Or you could use unit test if you prefer unit test. Hypothesis works well with every testing framework I know of. But you can also, let's just simplify this test suite a little. In a proof of concept, use a hypothesis backend that I'm writing called Hypofuzz to actually run this a little longer term. And let me pull up a new window to open this in. So Hypofuzz, instead of just running your tests 100 times each, will actually start running your tests over and over again, and it will keep running them indefinitely on a server until you tell it to stop. And at each step, it will look at the code coverage and steadily try to discover new behaviors of your code. And so this longer running process with more feedback can often end up discovering things that wouldn't have been discovered just by pure chance. In this case, we're not going to find anything because the standard library has been very well tested. So, let's see. That's my talk, Stop Writing Tests. I hope you consider using property-based testing and the ghostwriter, and I look forward to talking to you in the chat.
So that was a great talk. Pretty interesting topic if you look at it, right? Stop writing tests and automated testing. I mean, how much time as developers we spend in writing tests, right? So Zach is going to be around on Discord as well as the comment section. You guys can shout out your questions at him. He'd be there to answer. Hey, Zach.
Hello.
Hello.
Great to see you. I'm wearing my hypothesis pajamas. It was meant to be a t-shirt, but it came very, very thin.
Yeah, it was a great talk. I mean, I totally agree with the sentiment that, you know, we spend a lot of time writing manual code and testing, even the data generation as a developer, right? So if you have a better way of doing it, it does save a lot of time. And you can even detect the anomalous behavior by running multiple times, right? And if you have a different behavior than expected. So anything else you would like to add? Or something?
I think I said most of the important stuff in the talk, but a couple of other points are just how easy it can be to get started, but then you can extend use of hypothesis a long way. So I showed off the simple use cases in the talk, but similar frameworks have been used to test things like compilers. And that can be anything from generating valid programs. So I have a proof of concept to generate Python source code. Or at the more complicated end, you can do things like generate a random program and generate an input to it. Then compile it and run the compiled version on that input. And then delete or randomize any part of the code that was not covered by that input, compile the new program and run it on the same inputs. And you should get exactly the same result. But because optimizing compilers are really hard, you probably don't. You'll find a lot of compiler bugs by doing that. But overall, I guess my message is that we spend a lot of time on testing in ways that I think are kind of more boring and less valuable than we should. And so my goal is to build tools that let us get all the same value out of testing, but have more fun while doing it.
So how long have you been working on this, or working with hypothesis or this property-based testing in general?
So I've been a core developer of Hypothesis for about 4 years now. And the project was started before that in 2013 by David McKeever, who lives in London. So we collaborate entirely over the internet, pretty much. And it's been a fantastic collaborative effort between the two of us, but also about 300 other people who have contributed over the years. So it's been a fantastic community project.
Wow, that's awesome. So any tips you would want to give to all the beginners out there who want to get started with hypothesis testing? Because see, hypothesis word for a lot of people out there might be a little intimidating. So any tips?
Yeah. Let's see. My first tip is that all you need to know to be able to use hypothesis is the basics of Python. So if you're comfortable writing functions and you know what decorators do, that's the @ given over the top of a function. As soon as you've learned that, you can start using hypothesis. And I guess my main message would be, don't be scared. We probably spend most of our effort making sure that when something goes wrong, hypothesis gives you really helpful error messages. I sat down the other day and tried to work it out, and I think about 2/3 of hypothesis is just dedicated to making sure you can tell what goes wrong when something goes wrong. And it will. That's the whole point of hypothesis.
Sorry to interrupt, but we have a couple of questions on our YouTube channel as well.
Awesome.
All right. So one of them being, does hypothesis have a JavaScript version?
Hypothesis does not have a JavaScript version, at least not yet. But there are similar tools for JavaScript. If you search for JavaScript property-based testing, that would be the best way to find them.
All right. And the second question we have here is, what's the difference between, what's the difference between hypothesis and parameterize?
That's a great question. They're pretty similar in some ways. PyTest parameterize, you put the decorator on and you list out all the inputs to your test function. The distinction is that with hypothesis, you don't actually describe what those inputs are. You say, this is the kind of thing I want. For example, I want lists of integers. Whereas with the PyTest parameterize, you would have to think up every list of integers for yourself, or one of your colleagues would have to. And in particular, that means that hypothesis is more likely to think of things that you didn't think of. For example, is the empty list a valid list of integers? And should my function handle the empty list? I'm not likely to think to test that, especially if I forget an edge case when I write the code. I'm not usually going to remember it when I write the tests. But if I use hypothesis, the computer can think of that stuff for me. So I actually use both hypothesis and parameterize, and you can even use them on the same function. So you can say, take this argument from that list of parameters, and then for each parameter, generate more arguments with hypothesis.
Oh, wow. That's actually a great way to look at it. Could Ghostwriter help, not Ghostwriter the movie, but could Ghostwriter help integrate the two together?
It could. At the moment, the Ghostwriter will just always use hypothesis for everything, because the Ghostwriter doesn't insist on you using PyTest. You can have the Ghostwriter output unit test tests, for example. But where the Ghostwriter says sampled from this list, you could easily turn that into a parameterized decorator with the same list of inputs.
All right, so our next question is, I think it was directed partially towards me as well, but can you think of an example using hypothesis in a data science project?
I sure can. And there are 3 examples that I think are really cool for this. So the background is hypothesis has native support for generating NumPy objects, including arrays and data types, as well as pandas data frames. And so you can even say things like, give me any data frame and it will fill in the actual elements based on the column type, which is pretty cool. So we actually helped build that out for Stripe, who use it in their machine learning fraud detection pipeline for payments processing. That's the only corporate example that I can name offhand because I know they've blogged about it publicly. But hypothesis is also used in the NumPy test suite and the pandas test suite, as well as by projects like AstroPy. So scientists have used hypothesis to search for problems in their time handling. Because for most of us, the Python datetime object is fine, right? You rarely need to know the time to less than a microsecond of accuracy, or more than 8,000 years in the future. But if you're an astronomer, you care about nanoseconds, you care about all these enormously distant things. And so by using hypothesis, the AstroPy developers were able to discover that their date time handling was 100 billion times less precise than they thought it was.
Wow. Okay.
Wow.
For a whole 20 microsecond error over the age of the universe. Like for most of us, that doesn't sound like much, but the astronomers were very happy to find that out.
Well, to make matters worse, date time is always like, especially with the formatting, at least while working with it, it's always been very difficult to, get in a clean format. So I could think of like a couple of projects where, apart from astronomers as well, handling in clean datetime objects coming into your Python package and seeing, okay, at this point, if my format looks like that, it's going to break. Because if I'm not wrong, Pandas does have a 2 datetime conversion.
They do.
With it.
Yep.
Yeah, and you can check if you're able to handle all the formats coming in.
Yeah, and in fact, one of the things that Hypothesis found in the standard library, there's the datetime parse ISO format function. Paul Gansel, who maintains that module, found a seg fault in CPython, where if you had a particular Unicode character as the separator between the date and the time part, you could crash Python just by trying to parse a date time.
Wow.
Imagine being a Python developer and never touching C and seeing segmentation fault or something of that sort in your code. You're just going to go crazy.
Yeah.
What's going on?
I'm quite happy at the Python level. If you are writing C extensions in Python, though, Google has recently released a new fuzzer called Atheris, which can do joint code coverage of both your Python code and your C code. So you can actually fuzz your C code from Python, and you can use Hypothesis if you want to generate the actual test harness for that, and then run your test using this heavyweight tool.
That sounds great. Yep. I'll be a little honest here. Like at first, this is a little bit daunting. So could you direct us to some documentation or examples which are available in the documentation for Hypothesis?
Totally. So the documentation is at hypothesis.readthedocs.io. There are some examples already in there. But then my advice to get started actually would be see what it looks like with the Ghostwriter on your own code. And that'll show you simple tests, but on code that you actually care about. And you can see immediately like, that seems weird. How do I make that argument do something else, for example? And so it gives you a concrete starting point, but also some really clear options to take that further.
All right, that's great. Thank you so much, Zach. And I'll be heading over. Shivangi will be taking over for the next talk again.
Yeah.
Awesome.
Thank you, Zach. Just one more question before we conclude for the day. So as a developer, right, everyone talks about test-driven development, right? Usually, even for beginners, it's very daunting, the whole idea of test-driven development. Do you think Hypothesis would enable them or empower them to adopt to a more test-driven approach?
So test-driven development can mean a lot of things to different people. In the strict version, it means you always have to write the tests before you write the code. And I'll admit, I actually don't do that very often. But what I do is I try to make sure that I don't write very much code without also writing the tests for it. And Hypothesis is my preferred way of testing. I can get the same confidence in my code from writing one test function instead of writing 10 or 20 test functions. If you want to do strict test-driven development, Hypothesis is great for that, but you certainly don't need to do that to use Hypothesis.
Sure. Okay, Zach, it was wonderful talking to you. I think it's time for the next talk. And you'll be available on Discord and
I totally will.
Comments, right? Sure, we'll post our questions there.
All right. Thanks again, Shivangi.
Thank you, Zach. Bye.
Bye.
All right. So, hi, Amber. How are you doing today?
Hi, I'm doing well. How are you?
Good. So, all set for your talk?
I'm all set. I have my pajamas ready to go.
Cool. So let's get started. I'll just quickly just explain what you are going to be talking about. So Amber's actually going to talk about the power of performance feedback, right? And I'm just going to hand this over to you, and you can take it over. All right. All the best, Amber.
Awesome. Thank you so much. Thank you so much. So since we are going to be talking about performance feedback, I'm actually going to rely on a lot of from you. We're going to be practicing this in live time. So actually, to start off, I am going to ask you to go into the chat and give me some insights into how you are as a feedback giver, or how you are as a feedback giver right now. Give yourself a little bit of an assessment. Give me some feedback so I can address any questions, any challenges. What are some things that you're looking for in terms of performance feedback right now, in terms of this presentation? So I'm going to give you about 15 seconds to put, any questions that you have, any challenges that you're facing. How are you as a feedback giver right now? How are you as a feedback giver? All right, I'm looking, seeing a little bit. Okay, someone says, I'm doing good. Someone wants to know, how do I give feedback on that? Okay. All right, seeing a little bit. Okay, I have some feedback here. I'm actually going to give that response a 4 out of 10. 4 out of 10. Actually, I think we can do a little bit better. I got some feedback. I have some idea of what I need to address. But for you, I'm going to give you a 4 out of 10. This is a Likert scale. So this is one way that I can give feedback on your responses. So I think that we can do a little bit better. 4 out of 10, it's okay, but I think we can do a little bit better. So I'm going to ask the question again. I'm actually going to play a little bit of music this time and ask the question again. What are you looking for in this? What are you looking for in this presentation? What are some challenges that you're facing? How are you as a performance feedback giver today? And how are you looking to improve? All right, I'm seeing a little bit more here in this chat. I'm seeing a couple different chats are going on, so I'm trying to look at them all. All right, I'm gonna give you about 5 more seconds. 3, 2, 1. All right. Okay, that one was good. I have a few different types of feedback that I can give you. I'm going to use a checkbox method of feedback now. So beforehand, we used a Likert scale, so that's numbers only. This time, I'm going to give you a little bit different type of feedback on what those responses were. So this is a checkbox feedback. I actually want faster feedback. So if you could go into the chat and respond just a little bit faster. That one had a little bit of a lag. So if this were a checkbox, we checkbox on we want a little bit faster. I'd love for you to get a little bit more specific on what specifically what specifically are some challenges that you're facing in terms of giving performance feedback? What are you hoping to gain? What are you hoping to learn from this presentation? Be as specific as you can. And I'm looking for a specific quantity as well. So beforehand, we use checkbox. This time, I'm going to give you a different type of feedback. This is checkbox feedback. So I'm going to give you a chance to improve the feedback that you are giving me, the responses that you're giving me in terms of how you are doing with feedback in general. So I'm going to give you another chance. I'm going to put the clock back on for about 15 more seconds. Turn my music back on. Getting a little bit more, okay. Somebody said that they want how to get feedback at work. Okay. All right, I'm seeing a few different types of feedback. You have about 5 more seconds. Want to make sure that I address all of the challenges that you're facing today. I want to be specific in my specific performance. 2, 1. All right, this is our last go. I'm going to give you this time, actually, I'm going to give you a 7 out of 10. That was more information, so that was good. I'm going to give you passing, a 7 out of 10. This time, instead of using checkbox, I'm going to get a little bit more specific so that I can get strategic in improving my performance And so you can be strategic in improving your performance in giving these responses. So we got a 7 out of 10 last time on using the chat. This time I'm only going to give you 10 seconds. Last time I gave you 20. Only 10 seconds. I want you to give me some responses on some challenges and what you're looking to learn from in improving your performance feedback within your work teams specifically. And last time I told you quantity. Quantity can be kind of a vague word, right? That was some vague feedback that I gave you. This time I'm going to be even more specific. I only want 3 words, all right? Not more, not less. These are industry standards. We have some regulations. So I'm going to give you 10 seconds. Explain to me some challenges that you're facing at work. In 3 simple words, okay? We're about 5 minutes into this presentation. This is our last chance to see if we can improve. Ready, set, go. 10 seconds. 9, 8, 7, 6, 5, 4, 2. Stop. All right. Okay. I saw a little bit more. All right. I'm seeing some people are having some issues addressing conflict. Addressing poor performance, trying to be better communicators. All right. These are all things that we can address. So for this last one, I'm going to give you 10 out of 10. Very good. Very good. See, we're just a few minutes into our presentation and we've already improved our performance within giving responses just by altering the feedback that I could give you versus Likert scale versus checkbox, between getting a little bit more specific so that we could get strategic. And this brings me to a really important aspect of performance feedback. See, oftentimes we must first identify what performance expectations that we have of our team. What are the expectations that we have of our team, and why do we have those expectations? So in order to create an environment for great performance feedback, we must first identify 2 things. What expectations do we have of our team? What performance expectations do we have of our team? And why do we have those expectations? What expectations do we have and why do we have them? I know it sounds super simple, that actually what we do with the Pathways group and what I encourage you to do within your team is to actually sit down and spend a couple of minutes identifying what expectations you have. This could be, what are the expectations for answering emails in a timely manner, for showing up to meetings, whenever you're writing code, whenever you see code being written poorly. What are your expectations for confronting tension and for confronting conflict? This goes as large as the logistical standpoints of, okay, how are we operating as a team? It could be performance of the actual code that you're writing. It could be performance within you in your organization. Expectations, performance expectations can take on a variety of different methods. And oftentimes we might have expectations of our team members, but we don't necessarily communicate them. Well, uncommunicated performance expectations are doomed to be unmet performance expectations. And so we first must identify what expectations we have of our team, and then do a self-check and ask, have I really communicated those expectations to turn the tables around and ask the question in reverse? What expectations do my team members have of me? And am I meeting those expectations as well? Are there self-imposed expectations that I assume that the team wants me to do that it's really just something that I am expecting of myself? And having these honest conversations within your team and within your group lays a really powerful foundation for great performance within your team. It provides clarity of what we're doing and why we're doing it, and then providing opportunities for ownership within the how. Within teams and organizations, complexity can jade clarity. And so by clarifying expectations first, it creates an environment for better performance within our teams. Now, clarifying expectations and communicating expectations, that's really important, but at the end of the day, expectations still sometimes can go unmet, right? And so how do we actually address those situations whenever they naturally occur? Whenever we encounter teams and whenever I work within a new team, I encourage you to engage in proactive conversations. Now, proactive conversations is a quick 5-minute tool that I use whenever I come into a new team, whenever I am engaging with a new client, or whenever I'm working with my team on a new project. And see, a proactive conversation goes a little something like this. At some point in this project, I'm going to fail you. At some point in this working relationship, there is going to be conflict. There's going to be heat. There's going to be tension. And so while the emotions are low, let us proactively discuss how we are going to handle that situation whenever it inevitably arises. And this does a couple really powerful things. First, it normalizes tension. It normalizes some conflict within teams. Sometimes team members are hesitant to bring up unmet performance expectations because they don't want to admit that the tension is still there. They don't want to admit that there is heat within the working relationship. But by having a proactive conversation, you're saying not only does conflict happen within teams, we're actually expecting it to happen. The second thing that a proactive conversation does is it actually sets a game plan and it lays out a script for what will happen, what you can expect will happen whenever those conversations do arise. Many times people are hesitant to bring up different types of tension and conflict within teams because there's a bit of ambiguity on how that conversation is going to be taken. But with a proactive conversation, you can clearly lay out what you can expect whenever unmet performance expectations arise. So, you want to have proactive conversations. Now, proactive conversations also help us to overcome one of the greatest barriers to great performance feedback, and that is the fundamental attribution error. Now, the fundamental attribution error is the idea that too often times we judge other people by their behavior. So we judge other people simply by their performance while we judge ourselves by our intention. Surely we see this whenever we are writing code, whenever we're developing new products, whenever we are working on a problem, we might see the end behavior. But within ourselves, we see the intention. I was actually working with a team a couple of months ago, and there was a team member that was oftentimes seen as abrupt, seen as abrasive. Some even said malicious. And so we kept in mind the fundamental attribution error. And so I went up to the team member and I asked, what is your intention whenever you are speaking in meetings? And the team member was intending to be passionate, intending to be persuasive. And so by being mindful of the fundamental attribution error and instead asking the question, what is your intention? We actually discovered a knowledge gap between intended behavior and perceived behavior or actual behavior. And so we were able to approach the conversation from more of a coaching angle to bring the two closer together. And so by simply rephrasing that question of what is your intention, we were able to enter into the conversation from more of a coaching relationship to partner with the individual to improve behavior as a whole. Now, whether it's having a proactive conversation or addressing unmet performance expectations, in any case, it's important that we get specific so that we can get strategic. In a former life, I was a football coach for a major sports, for a major football academy. And whenever I was coaching sports, I actually found that there were three major purposes to performance feedback to improve our performance. And in all three cases, it's important for us to get specific, to get strategic. See, the first purpose of performance feedback is to encourage great performance. We want to encourage great performance. I recall as a football coach, I would hear other coaches and hear team members enthusiastically say, "Great job, you're doing awesome, keep up the good work, well done." And while this may sound really great, the player walks away feeling really good about themselves, but not exactly knowing what behavior, what specific performance we want to encourage. What specific performance do we want repeated? And so I encouraged our coaches, encouraged the other players to get very specific so that we could get strategic in improving performance. So rather than saying good job, I want you to go a step further and say good job at making clear passes. Right, so that's what we did in football is we said one step further, say good job at this specific behavior. And this way we're getting specific so that we can get strategic to improve on a later, improve for the future. On the other end of the spectrum, the next purpose of performance feedback is to correct undesired behavior. So this is on the other end of the spectrum. Also, whenever I was coaching football, I would have a young lad that loved to come into the locker room whenever we were losing a football match. And he would say, "Guys, I know exactly what we need to do to win the game. We just need to play better." And while the player was technically correct, it wasn't specific enough that we could do anything really with those words. We couldn't really do a lot with that performance feedback. And so we actually needed to be more specific by asking more series of what and why so that we could get strategic to improve our performance to actually win the match. So next we needed to correct. And then last but not least, the third purpose of performance feedback is to coach. Or to build upon current behavior. Coaching could also include teaching new performance or new behavior. So coaching is not so much encouraging, I want you to continue doing one thing, or correcting, stop doing another. Coaching is on a different level of, okay, we're going to build off of the current behavior that we have. And in this scenario also, we want to get very specific so we can actually have true improvement within our performance. Now, knowing the purpose of your feedback, stopping to ask yourself this really quick question: what is my desired end goal with this conversation? Can completely shape the framework that you can use whenever you're having this conversation, right? So rather than saying, oh, I'm really frustrated with this person's performance, or hey, I really like this person's performance, ask yourself at the end of this conversation, have I effectively encouraged desired behavior, corrected or coached behavior within my team? Have I been specific so I can be strategic within my actual team? This is a skill that we used whenever I was working with football teams all over the world. And so these are things that you can use within your organization today. Now, I have one last thing. I have many people ask me, okay, Amber, this is all good and fine, but how often should I be giving this feedback? Especially right now within our remote teams and working with a variety of teams all over, studies are showing an average of 2 to 3 times minimum per week of informal feedback. So informal performance feedback is going to be a quick email. It could be verbal feedback. It's going to be just everyday conversation that you're going to have. So that is on average desired 2 to 3 times minimum per week. So that's a lot of feedback that we're going to be getting. Then on the other end of the spectrum, you have formal feedback, and that's going to be formalized in some sort of a documented report of some kind what your performance is. This is not an annual review that we have in December where we discuss performance that happened in February. The average, most effective pace in which we can give formal feedback is either bi-monthly or quarterly. So that's going to be 4 to 6 times per year that we are getting formal feedback, giving us the opportunity to improve our behavior, keeping this framework in mind so that we can improve our performance within our team. And then at the end of the year, if we want to have an annual review, then that annual review is actually just a summation of all of the formal feedback that we've gotten across the course of the entire year. And so whether it be informal feedback or formal feedback, there are a lot of different ways that we can adjust the pace in which we are giving our feedback so that whenever people receive feedback, they have time to digest the words that have been given. They have time to digest the feedback that they've been given. They have time to come up with a game plan on how to improve that performance, or you can work with them to improve that performance, implement that game plan, and allow others to see the results of that game plan altogether. Now, I've given you a lot of information. This is a lot of information in a short amount of time. So it really does remind me back on the football pitch of a young lad that I actually used to coach, and his name was Achintya, and he was about 6 years old. And he had a lot of information. He had just started learning about football. He learned a lot of new words. And so he came running out onto the pitch, and he began yelling, "Pass, pass, pass!" And I noticed at that time that Achintya was yelling pass even whenever the other team had the ball. And he was yelling pass whenever he was miles away from the action. And he was yelling pass even whenever he had the ball. So he was running with the ball going, pass, pass, pass. And so I looked at Achintya and I said, "Achintya, why are you yelling pass?" And he looked up at me and he said, "Miss Ammerman, I do not know what it means. I only know it as a football word." And it can be easy to hear a lot of these different words that we've talked about today and say, proactive conversation, fundamental attribution error, get specific to get strategic, encourage, correct. Because we know that these can score really big goals. But if we're in the wrong position, then it can actually be detrimental to our overall communication within the team. But we first take the time to clarify our expectations, communicate performance expectations within our team, have proactive conversations, and then be very specific so that we can get strategic to encourage, correct, and coach performance within our teams. Then we'll be in a position to yell pass. to receive the ball, to move forward, and to score really big goals. Thank you so much for having me today. My name is Amber Vanderburg, and I am here with the Pathways Group. I would love to answer any questions. LinkedIn, YouTube, I'm the only Amber Vanderburg on any social media. So I'd love to connect any way that you can if you have any questions or anything about performance feedback as well. And with that, yeah, we'll be good to go. Uh-oh, I can see you, but I can't hear you.
Sorry.
Hey, I think Shivangi forgot to unmute.
There you go.
Yeah. So it was a wonderful talk. Yeah. And we learned a lot, like you said, right? A lot of words and jargons are regarding performance, but I definitely can relate to the situations you were trying to portray. Just one quick question I had regarding performance feedback, right? I know we say it's very important to give feedback, but usually people are not very good at receiving them. As good as it is to give feedback, you should also be a good receptor. Or what do you do with people who aren't very receptive to feedback, right? Whether it's constructive for them or whether it's formal and informal, right? Some people just don't want to listen.
Okay, you
So
kind of cut out, but I think I understood the question. About receiving feedback. I think from a personal level, I have to ask myself these questions as well. Especially with proactive conversations, that's a two-way street, right? So there have been times that someone might come to me with some feedback that I don't want to hear, but we've already had the conversation that I'm going to respond this way and we're going to respond in kind. Same way with the fundamental attribution error. It can be easy for me to say, oh my gosh, that person, what were they thinking? Like that was such, a horrible performance there. But instead I have to ask, okay, well, what was your intention? Or you were doing that. And so I think from the receiving level, I have to kind of turn these tables on myself as well, so that I have to do a self-check to say, okay, am I the thing about performance feedback is it's a personal thing, right? This is your personal performance. So it can be extremely easy to want to put defenses up and putting defenses up very, very quickly. So understanding your intent is very huge. On the other end, if you have someone that is not receiving feedback well, so I think there's a two-part question of that is how do I receive feedback better? And then what do I do if someone is not receiving it well? If someone's not receiving it well, there's a couple different things that I do. First off, I do ask, what are you trying to do? And rather than enter into the conversation from a reprimanding or managerial, I actually come from more of a partnership of, okay, how can we work together to improve this performance as a whole? And that's a completely different dynamic than stop doing that. So saying, okay, this is not good. We need to stop doing this. Doing things like that it comes off a little bit more reprimanding. Approach. Generally, feedback is better received then. I've also had some people say, hey, I think that my performance is great right now. I don't see what needs to be improved at this point. What needs to be corrected. And from there, I also changed the dialogue just slightly. This isn't a massive shift. It's actually just a slight pivot and say, okay, what we have is good here. Just go ahead and concede that. Okay, let's say if you say this is good, okay, that's fine. What if we made it even a little bit better? And coming at it from a conversation of, hey, can we improve just a little bit more, can actually change that dynamic. And so being very aware of team dynamics and relational dynamics oftentimes massively affects the effectiveness of performance feedback being received, both personally and with other team members as well.
Yeah. Thank you, Amber, for the wonderful talk. I think there are a couple of questions for you on YouTube as well. You can check them out and answer them. I think I'll be handing this over to Sangarshnan now for the next talk.
Awesome.
Sangarshnan, you're up next. Thank you, Amber.
Thank you very much.
All right. Hey everyone. I hope you can hear me. Can you guys give me like? All right. Awesome. Cool. So I think it's time for our next talk. Our next talk is from Julin Shaji. He's been using Python for 5 years and he's interested in text processing. And today he's going to talk to us about publishing, well-formed Python packages. Uh, oops. Oops. Yes. Oh yeah. Sorry, I think I shared my stream without the audio. Is that right? All right. Let me just try again. So this talk is for 25 minutes, so I guess we have time. Uh, Share audio.
Hi, I'm Julin.
Yeah.
Welcome to my talk about
Thank you,
publishing
bye.
well-formed Python packages. In this talk, I'll mention some ways in which we can make our packages well-formed so that they are easier to work with. But what do we mean by a well-formed package? Well, the main objective behind making a package well-formed is to make its maintenance easier so that we need not spend too much time fixing problems, which could have been avoided or at least minimized in the first place had we taken care of certain aspects of our package as we were developing it. A well-formed package is well-structured, well-organized, and follows certain practices which leads to quality code. This will help make things easier for the community that use and develop that project, as it paves the way for smoother collaboration between the members of the community, and there are less chances of confusion creeping in. We can make any changes as we need as per the changing requirements. If you want, we can make changes to such a project in a less chaotic manner because our package is well formed. So how can we do that? How can we make our packages well formed? Sufficient documentation, proper test, and a few related stuff can help. Let's take a closer look. This is an overview of the topics that I plan to cover today, all the way from the linting and styling aspects of the code itself, through static type checking, unit testing, and all the way to the actual packaging and publishing aspects of the package itself. And let's begin with linting and styling. One of the first things that you can do to make your package well formed is to adopt a suitable coding style and enforce that coding style using linting tools. It's good to have the suggestions mentioned in PEP 8 in mind when you're choosing your coding style, because as we all know, it has got a lot of good suggestions which have turned out to be quite good. So it would be good to keep that in mind. And using these linting tools will help our code achieve a more consistent formatting so that it will be more readable. And of course, a readable code is extremely important in order for the project to be maintainable, because as they say, code is more often read than written. So we need the code to be easy to read, so that when we read it in later on to make changes and all, we will know what exactly it is doing faster, so that we can get things done in an easier way. And using linting tools, we can also, these linting tools are also capable of finding subtle bugs that may have crept into our code without us realizing it. For example, like an argument of a function may be having a default value, which is a list. And that's not a good thing because a list is mutable. And if while we keep calling that function again and again, the list value will keep changing. So the default argument value will be different that what we may be expecting from the second function call onwards. So the linting tool can help us help us spot that in an easier way. It will say, hey, this looks bad, you may want to change that. The linting tool will tell us that, and we can make the appropriate changes. Pylint and flagate are some of the commonly used popular linting tools for Python that we have. The default values are good enough, but if you want to change any rules, they are quite configurable. And there are code formatting tools like Black. In the case of linting tools that we saw earlier, like Pylint and flagate, we would have to run those commands every time we make any change to our code base to see if something is missing or something is going wrong, or the formatting is wrong, things like that. And as time goes on, you may find that you're spending more time than is ideal just to fix the formatting aspect of your code. But if you are okay with letting an external tool take control over the code formatting part of your project, you could use a tool like Black. Black is an automatic code reformatting tool which takes your code as input and formats them in a way that it thinks is the best. It has its own opinions regarding the idea of a well-formatted code, which is the reason why it is called an opinionated code formatting tool. But Black is useful in the case where a lot of people are working together on the project, and each member working on that project can write their code in a different style. Each one of them can use a different style. But after you run Black on this code, it will just look the same as if it has been written using the same code throughout. It doesn't matter. So we no longer have to worry about the code formatting. Black will do that for you. This means that you can focus more on the code itself than on the code formatting. Another mechanism that can help us make our package well-formed is static type checking. Python had been supporting type annotations for quite a while now. Actually, taking advantage of it not only improves the readability of your code without having any effect on the program execution part, but also allows us to run a static type checks. So in a way, we can sort of combine the advantages of a statically typed language in a dynamic language like Python, which offers us more flexibility as well. So these static type checks can help us uncover bugs and errors, incorrect usages, which would have led to some very puzzling errors. But thanks to static type checking, it is more possible for us to figure it out on our own without actually ever having to execute the program itself. So there are a lot of tools available for performing static type checks in Python code. And among them is MyPy, PyType, and PyRay. Another cause for concern is dead code. As the project evolves, it is easy for it to have some dead code accumulated with it. This dead code may not actually cause trouble at once as soon as it becomes dead code, but will be quite capable of causing trouble by interfering with the rest of the code later on when the conditions are right for that dead code to become active. And this can lead to some unexpected results, the reasons for which can be quite hard to figure out because of the existence of dead code. So to be safe, it's always a good idea to ensure that the project doesn't have any dead code. There are tools available for us to which will help us identify the dead code so that they may be removed. We can use tools like PyFlakes and Vultr to identify dead code. Now that we have our project with its style, type checking, and dead code taken care of, we need to verify that the code works as we expect it to work. That it returns the values that we want it to return and accepts the kind of parameters that we want it to accept. So we can do unit testing for that. So testing is one of the main things that make maintenance easier in our course, in our quest for making our packages well formed. Because we can make changes to selected portions of the code without worrying about its effect, without worrying about it interfering with the behavior of the remaining code. Because after any change, after making changes to some parts of your code, we can run the test for the remaining part of the code to ensure, to verify that the changes that we made to some other part of the code does not change the behavior of the rest of the code. So it's as easy as running the unit test for that, for those code segments. So we need not worry about some changes interfering with the rest of the code. So this makes actually modifications to the code base way more easier and a peaceful experience. So there are many testing tools and frameworks available for Python, and among them is the built-in unit test, which is a part of the Python standard library, and the third-party PyTest. PyTest is quite popular due to its simplicity, ease of use, and rich features. For example, things like fixtures and parameterized test is much more straightforward and easy to learn and use when compared to the equivalent features offered in the unit test module. So let us consider an example for unit testing. So for this example, I'm using PyTest, and I have a similar function strcmp as earlier, which accepts two arguments, x and y, two strings, and I expect it to return -1 when x is less than y, and 1 if x is greater than y, and 0 if both x and y have the same values. So I will have written a test like this. I pass chicken and egg as the values of x and y to strcmp. And of course, I mean strcmp for these arguments to return -1 because that's how it is supposed to work. Yet, running PyTest on it says that something went wrong. strcmp is not behaving as I expected it to work because it returned 1 instead of -1. So what went wrong? Let's take a closer look at strcmp. Obvious that what went wrong here, because once we actually take a look at it, these two lines are what is causing the problems. These if statements somehow got swapped. Maybe while making modifications, well, maybe we wrote it right at first, and maybe it went wrong. Somehow the if statements got swapped. But we still think that it is working as we expect it to work. But it isn't actually. So running this unit test will help us realize if something went wrong in between, even if it was working right earlier. So it is important to run unit test before actually releasing your code, before publishing your code, because of such errors that can creep in. So let's fix this and swap these if statements back. So now I run the test again, and it passed. So unit tests are helpful. But having your code tested alone is not enough. We need to make sure that our tests actually cover all the relevant parts of the code that we were testing. Because otherwise there will be, we might as well not have a lot of test cases anyway. We can use appropriate tools, coverage measurement tools, to see which all statements, which all parts of the code that we missed, and add appropriate test cases as we see fit to cover those parts of code as well. But having good coverage is nice, but striving for literally 100% coverage may not always be worth the effort. Because, for example, maybe your if main part will only have a call to a function, maybe just one line, a call to a function, which would be being tested anyway. So instead of we need not actually cover that as well, right? We can, because it consists only of a function call which is being tested anyway. So our coverage measurement tool by default will probably say that part of code, that single line is not covered, but it doesn't matter anyway, right? That's right. So we can use, there are many coverage measurement tools available for Python programs. And the most prominent one is probably coverage.py. And PyTest also has a plugin, a PyTest Co, that makes use of coverage.py. Which, so if you're using both PyTest and coverage.py and wish to have greater, want them to work with each other in a more close fashion, maybe you'll be better off using PyTest Co. So let us consider an example to illustrate the use of coverage. I have the same function strcmp here, which accepts two arguments, two strings x and y, and compares them and returns an integer value. I have the same test case which passes chicken and egg as the values of x and y to strcmp. But running coverage test on this test coverage on this function for this particular test set of tests, actually only one test in this set, will say that we have only 50% coverage. And those three lines highlighted in red are not covered by our test. Of course, our test case, chicken and egg, considers the x less than y case alone. We are not testing for the x greater than y or x equal to y cases. So we are, out of the three branches, we are testing only one branch. So if something went wrong on the untested branches, we would not know it because our test cases do not cover it. So that's the use of test coverage. So we add some extra assert statements to cover the two remaining branches as well. And now if you run coverage, it will say 100% coverage. Now we have our unit test ready. We also have some other checks like static type checks and linting and style checks that we need to run on our code base every now and then. And we also need to be sure that our package works properly in all the supported environments. These environments may be running on, maybe having different Python versions, or maybe even different Python implementations. For example, consider the valorous operator, which is available only from Python 3.8 onwards. Suppose that we used it unknowingly in our code base, which was supposed to work even on an older version, like Python 3.6. And if your local system is using 3.8 or newer, running your test on your own system will not show any error because it is okay. The valorous operator is supported there. But if you run it on an older version, it will give you an error. And running our test in all the supported versions every now and then sounds like a lot of work. So we can automate it using a test automation tool like Tox or Nox. But running our test in some certain configurations and package layouts can lead to misleading results. It may cause some tests to accidentally pass. That is, the test may not have actually passed, but it will show as it has passed. Let's take a closer look. By package layout, we mean the way in which the files and directories of the project are organized inside the project directory. There are many possible layouts. Two of the commonly used package layouts is the flat layout and the SRC layout. In the case of flat layout, the project source code as shown here under the package name directory, and the test of the package under the test directory comes under the same level, under the same directory level. Whereas in the case of SRC layout, the source code under the package name directory is isolated from the test directory by adding another directory level. It's nested in another directory. Tools like Tox actually create a separate virtual environment to which your package is built and installed, and your tests are actually run in that virtual environment, in that separate virtual environment, not in your own in the pre-existing environment. It actually creates its own virtual environment for you to run those tests. But in the case of a flat layout, if you are using tools like Talks in a flat layout, but the Talks will create a separate virtual environment, and the packages installed in that virtual environment will be in that vn lib site packages directory. So your package, I mean, the test in your package is expected to import the packages from the virtual environment itself. But if you are using a flat layout, because of the way the Python import system works, it will actually import, the test will import the modules from the package, the source directory itself, instead of importing them from the virtual environment's package directory, site packages directory. So if you're running tests like that, you're not exactly running in a virtual environment. You lose the benefit of running the test in isolated manner in a virtual environment. But if you're running it in a SRC layout, it is impossible for the test in the test directory to import directly from the package name directory, from the source directory itself, because it is separated, isolated using another directory level by placing it inside another directory, like named here as SRC. So in such a condition, the test would import from the site packages directory of the virtual environment itself and will work as we expect it to work. So that is an advantage of SRC. There is no officially recommended layout for a Python project. The Python community has not agreed upon a standard layout. You pick the one that you find will work better for you. For smaller packages, you may be okay working with flat layouts. But for more complex packages, especially packages having sub-packages, you're probably better off using a SRC layout. You can check out these links to see some interesting discussions about the package layouts and the way this configuration affect the way the tests are run. So once you have your project ready and you're satisfied with its quality and the test all pass, you will want to share your work with others. You will want to package it. So for that, you create a file which can be used to install your module, your project, your package into other systems. This process is called packaging, and the result is a package. There are many tools which can be used to create packages for Python, and that includes the setup tools from PyPI, the Python Packaging Authority, and there are newer tools like Flit and Poetry. So once you have your package built and it is ready for distribution, you can upload it to a server from where others can download and install it. Usually people upload it to the pypi.org server, but it would be better if you are new to this, it would be better to try to upload it to the test.pypi.org server. It is exactly like the actual pypi.org server, except that it is for the test purposes, to see if your package is okay being uploaded to the server, and then we can actually check if installing and downloading and installing from that server actually keeps the package working as we expect it to work. To do the publishing part, you can use tools like Twine. For setup tools, you can use Twine, and in the case of Flit and Poetry, they can do the publishing part as well by themselves. But of course, Twine can be used to publish independent of the package of the tool used to do the package your project. Apart from the tools that I have mentioned so far, there are a lot of other tools you can use for your project. So like a bump version, which can be used to change the version number of your package. If you're using bump version, changing your version number is as easy as running a command. And it can also be used to add tags. I mean, if you can use tags automatically while you're changing your version. And there's pre-commit, which can be used to run commands like black or pylon every time you commit, you make a commit to your project. And there is ISOR, which can be used to it can be used to sort your imports in a good manner. And there's cookie cutter, which is especially useful if you're using setup tools to make your project, because setup tools has a lot of files which you need to be set up when you're beginning your package. Going forward, what can we expect? Now the PyProject.toml file can become the center point around which the package revolves. Earlier, it just used to be setup tools for packaging, and now alternatives like Flit and Poetry have come up. Thanks to some proposals that have been accepted by the Python community, we now have the option for choosing the build system of our choice by specifying it in the PyProject.toml file. And discussions are ongoing to standardize the project metadata as well. So it can be stored in the PyProject.toml file directly, from where it can be used by the packaging tool of your choice. And because of the TOML file becoming more prominent, maybe we can expect a TOML module, a module which can parse TOML files in the standard library as well. So now we have come to the end of the presentation. Let's have a quick recap of what we saw so far. So we talked about linting and styling, and static type checking using tools like MyPy, and eliminating dead code, identifying dead code, and so that it can be eliminated later by using tools like Vultr and Pipeflake. Then unit testing, test coverage, and test automation, and finally packaging and publishing. So that's it. Thanks for listening. And if you got any questions or suggestions, I'll be happy to listen to.
Oh, hey everyone, thank you so much, Julin, for that talk. I think this is a recorded talk, but Julin is on the YouTube chat and he has been, answering questions and responding. So if you have any questions, you can just feel free to just reach out to him on the chat on YouTube. So our next speaker is already here and we have just 1 minute to go. So without further ado, I'm going to welcome Vishrut Kohli. He's a software development engineer at Grofers. Hey Vishrut, hi.
Hi, how are you?
I'm good. How are you?
Pretty good.
All right. How excited are you for your talk?
I'm really excited.
Awesome. So I think you can just share your screen. He's going to talk to us. I think have you already shared your screen?
Yeah.
You have. Awesome. So he's going to talk to us about building production-ready distributed task queue system with Celery. So I'm going to just add your screen. We can see it. Awesome. So you can just get started. I'm going to just get out. All the best.
Thank you. So, all right. So, hi everyone. I am Vishrut Kohli. First of all, I would like to thank all of you for attending this talk, and I'm really excited to be here. So, I started working with Python, or should I say, fell in love with Python in my early days of college, and now I am using it as my primary tech stack at work, where we use it at tremendous scale. I am working as a software engineer at Grofers. If you do not know about Grofers, it is one of the most popular grocery e-commerce in India. If you want to chat about anything else or about this talk, you can reach me through my LinkedIn or through my personal portfolio. So without further ado, let's dive into the good stuff. So today we are going to see how to build a production-ready distributed task queue management system with Celery. So when I say production ready, I mean 4 things. It's highly efficient, it is scalable, it is transparent, and it is resilient. So in this talk, we are going to cover what are task queues and why we need them, what is and why Celery, building a distributed task queuing system, tuning it to get maximum performance, adding resiliency or self-healing capabilities to the system, what to do in times of SOS or emergencies, monitoring the system we built, and most importantly, bad jokes. So I have tried to make this talk as descriptive as possible, but still there are some prerequisites like some basic knowledge of Python, some basic knowledge of web development, worked or even heard about celery before, and the most important one is a sense of humor and a love for gifs. So, why task queues? So let's assume I own a mall and I want to keep track of how many people are entering in my mall. So I installed a small IoT sensor at my entrance, and whenever someone enters my mall, it shoots an API request to my web server. Then the request goes to the database and increments a counter. And at the end of the day, I can just check my database and see the count. This system was working pretty well for me, but one day I thought I'll stream a football match in my mall. So a lot of people came to the mall, and I was really excited to see the numbers in my database. But when I checked the database, the numbers I observed were relatively low, and I knew something was not right. So I investigated and figured out when a lot of people entered my mall, for each person, an API request was raised to my web server, and there were a lot of concurrent requests trying to talk to the database. And due to the atomicity and locking at my database, many requests were timed out, and that's why the low count in the database. So there's got to be a better way. And there is. Task queues come to rescue. So let's see what are task queues. So if someone asked me this question when I was giving my university examinations, I would have answered task queue is a queue of tasks. And that is exactly what it is. I don't know why teachers don't like those answers, but yeah, it fits perfectly here. So now in the new architecture, whenever we get a request from my web server, instead of going and trying to increment the counter in the database, it puts it into the task queue and returns a 200 response. And now the DB can consume the request from the task queue at its own pace. So now we moved from a more real-time approach to a more eventually consistent type of approach. And that is okay for us because I only needed to see the DB at the end of the day. So what is and why celery? So you must have heard a lot about task queues. There are a bunch of them available like Amazon SQS, Redis, Amazon MQ, RabbitMQ. But building a consumption and publishing mechanism for those task queues is not that straightforward. To help us with that, Celery gives us a plug-and-play task queue management framework, with which we can manage our task queues with ease. So in this talk, we are going to use some keywords. So let's just iterate over them once. We already know what task queues are from our previous example, but we'll just say it again. Task queues are queue of tasks. Then there is task. A task is the basic unit of work of a task queue. And a task queue can contain n number of tasks. Then here comes the worker. Worker is the basic unit of computation which lies outside your application and where a task is processed. Then in line, there is broker. So broker in layman language helps us with picking an offloaded task, putting it into the task queue, delivering the task to the worker from the task queue whenever the worker wants to process it. And the last one is result backend. So it is a highly available database which is used by Celery to keep track of all the tasks and their results along with storing all kind of metadata for Celery. So some examples for result backend can be meme cache, Redis, etc. So okay, so before we start building the system, one question arises: which broker to choose? So there are a bunch of brokers available like RabbitMQ, Redis, etc. They all are great pieces of software, but works best for their own specific use cases. So for example, I'll cover the most common ones, RabbitMQ and Redis. So if you're looking for a highly efficient broker which supports several workers consuming from different queues and also offers some kind of persistence of task when it shuts down, then no doubt RabbitMQ is the way to go. But RabbitMQ is a little time consuming to set up and maintain. On the other hand, if you just want to use your broker as a quick messaging system, Redis is the way to go as it works really well for quick tasks and is very easy to set up too. Okay, so let's start building the system. So let's think of an e-commerce warehouse to build, and there are going to be three things which happen there: picking of the products, packing of the products, and delivery of the order. So the most basic kind of architecture for my warehouse would be something like this. I have one boy who picks up the products, packs the products and delivers them. And this worked for me for some time, but now the orders are increasing, and I want to scale my operations. So I also employed a girl in the same warehouse. Now they both are parallelly picking, packing, and delivering the products. And this is fine, as when more orders will start coming, I'll just add more people in the warehouse. But I think I can improve it a bit further, as I know that these two people are really good at picking, but they are lousy at packing and they don't even have delivery bikes to deliver. So, what if we break this work into smaller fragments and get specialized people to do what they do best? So, now these two people are just doing the picking. I added an experienced packer who has its own packaging station and everything, and added people with delivery bikes to deliver more efficiently. So this way, we had one big task, we broke it into smaller fragments and executed them in order. And now in further slides, we will call this our pipeline. So why should we even use pipelines? There are a bunch of advantages we get while using pipelines. So let's go by them one by one. First, it gives you the ability to see bottlenecks and scale smaller components of the system instead of the whole system. So for example, so now if I see there are a lot of orders pending to be packed, so I can just add more people in the packing worker and scale the packing operations instead of scaling the whole pipeline like we did earlier. Second, this will give the ability to give different kind of machines to different tasks. So as per in our example, we can see the packing worker needs a packaging station, but a delivery worker needs a delivery bike. The same thing happens with the tech system. Different tasks need different kind of infrastructure. Some might need more CPU, some might need more memory. Third, it helps us keep track of statuses of tasks, which will add some kind of resiliency to the system by enabling retries at every step. So now, if a task fails, it will not retry from the beginning, but will get retried from the last checkpoint or last succeeded task in the pipeline. Okay, so now let's assume we have a sale going on and we have a lot of orders pouring in. Our warehouse is already full and we can't even add more people to the warehouse. So we got two ways here. First thing is, we can buy a bigger warehouse, move all the operations to the bigger warehouse, and add more people in. In tech terms, we call it vertical scaling. On the other hand, we can purchase a makeshift warehouse of the same size, add more people there, and run these two warehouses in parallel whilst the operations inside them are concurrent. In tech terms, we call it horizontal scaling. In my case, horizontal scaling makes more sense as the number of orders are variable, and after the sale ends, one warehouse would be able to cater all the orders alone. So, the code for our application would look something like this. We have an order receiver API which receives an order and offload it to the picking worker, which is the entry point in our pipeline. And the code for our pipeline is something like this. It starts with the picking worker, which picks up stuff from the aisle, passes it to the packing worker. The packing worker packs the stuff and passes it to the delivery worker. And in the last, the delivery worker delivers the stuff in time and makes the customer happy. So now we have built our celery system, but we don't know how well it performs. So first things first, it's always better benchmark before moving to any optimization. Because in my experience, I have seen if we go by intuition, either we end up over optimizing the system or optimizing wrong parts of the architecture. So for example, in our pipeline, when I ran a load test, I saw the number of tasks queued at the picking worker were much higher than any other worker. So I knew from where I have to start optimizing. So let's ask ourselves one question. Can we use batching? So let's assume what happens in the picking task. Here in the picking task, a person is assigned an order, it goes to the aisle, picks up that order, and passes it to the packing worker. Now assume you have a lot of orders coming in, and to cater them, you added a lot of people in the picking worker, and everyone is trying to get something from the aisle. As lots of people are crowding the aisle, there will be some kind of wait time for everyone to pick their order. The exact same thing happens in our concurrent systems. The IL acts as our database, and people act as our concurrent threads. To solve this problem, we can introduce batching. So instead of one person picking up just one order, we can make one person pick up 10 orders or even more. This way, we are decreasing our trips to the aisle by 10 times. But as we know, every good thing also comes with a trade-off. So now your retries and failures also happen at batch level. So if the ninth order failed for some reason in a batch of 10, still the whole batch of 10 will be retried. So if you're okay with this trade-off, then this can definitely decrease the load at your DB and give some kind of performance boost. So there is not much change in the code for our application, but instead of offloading it to the picking worker like before, we will offload it to the order aggregator worker. And the pipeline is also pretty much the same, just one more task named order aggregator is added, which contains the order chunking logic. And instead of passing just one order to the picking worker, it passes a chunk of orders to the picking worker. So the next optimization would be always split tasks into IO bound and CPU bound tasks. So IO bound tasks are tasks in which a thread blocks the CPU and waits until an input or output is received. This makes the CPU unusable for the time it's just waiting. These kinds of tasks can be optimized with the help of gevent or eventlet tools, which help us enable a non-blocking IO approach in which the thread goes to the CPU, registers its request, but does not block the CPU, and whenever its input or output is ready, the CPU raises a callback and the thread goes and collects it. This way, our CPU is never blocked by concurrent IO processes. On the other hand, a CPU-bound task is a task which uses the CPU for crunching numbers or doing other CPU-intensive tasks. For these kinds of tasks, we should use a pre-fork tool as it is based on Python's multiprocessing module and helps running parallel processes on multiple cores. And it's very easy to set up too. You just need to pass the pool name and the desired concurrency needed in the following command, and you will spin up a worker with the provided configuration in no time. Okay, use O-fare optimization when possible. So this is quite interesting. So the default approach Celery uses is the round robin approach to distribute tasks among distributed systems. So if you have a set of tasks that take varying amount of time to complete, either deliberately or due to some unpredictable network conditions, this will cause unexpected delays in total execution time for tasks in the queue, as you might end up having some tasks queued at some worker whilst some workers are idle. To solve this problem, we can use O-fare optimization, which distributes tasks according to the availability of workers instead of the number of workers available. So this option comes with a coordination cost penalty, but results in a much more predictable behavior if your tasks have varying execution times, as most IO-bound tasks will. So keeping track of results only if you need them. So as I told you about result backend, which stores all the metadata, statuses, and results of Celery, if you know you're not going to use them anywhere in your application, you can decrease the amount of network cost to your highly available database, and it can give you some amount of optimization. So now we will see how to add some kind of resiliency or self-healing capability to the system. So I think we all agree what Sentry.io's tagline is: software errors are inevitable, but chaos is not. So the most basic version of resiliency is to enable auto retries in times of failures. And you can add circuit breaking element. For example, uh, I have added 5 as the max number of retries. And if a task is retried 5 times and still failed, it will be ignored. To make it more resilient, we can add exponential backoff. So for example, your task is dependent on another service, and that service is down, and let's assume the time between consecutive retries is 10 seconds. So if the service is down and my first retry will happen at 10 seconds, the second one at 20 seconds, the third one at 30 seconds, the fourth one at 40 seconds, and the last one at 50 seconds. So in this case, I gave 50 seconds breathing time to the other service to come back up so that I don't lose my task. So to increase the amount of breathing time, we can use exponential backoff, which means the first retry will happen at 10 seconds, the second one at 20 seconds, the third one at 40 seconds, the fourth one at 80 seconds, and the last one at 160 seconds. So now the breathing time is increased from 50 seconds to 160 seconds. And if you want more breathing time, you can change the exponential backoff. Uh, the next one is acts late is equal to true. This means late acknowledgement. So by default, a broker marks a task as acknowledged when it delivers it to the worker. But if our worker goes down and restart, it loses that task. So to make the task resilient towards worker failures or infrastructure failures, we can use acts late is equal to true, which means until and unless the tasks is processed by the worker, it will not be marked acknowledged. So even if the worker goes down, the broker delivers the same task to it as it was still stored in the broker and was unacknowledged. And the last argument is retry jitter is equal to true. This param is used to add some kind of randomness to the system. So let's assume we have a concurrent system and there are chances two tasks are trying to access the same database resource. When they execute, they will form a deadlock and fail. We have our automatic retries enabled. So they'll get retried at the same time again, form a deadlock and fail again. And this will repeat till the circuit breaks. In situations like these, we would want some kind of randomness to the retries so that they do not get retried again and again at the same time. And that is why retry jitter is helpful. And if you want to keep track of all your circuit break failures, you can use a DL queue or a dead little queue to store your field tasks. Okay, so when your system is down, the first thing you should do is check your CPU and memory utilization. If your CPU utilization is high, then horizontally or vertically scaling according to your infrastructure could help. But if your memory utilization is high and you know for a fact that your code is not using that kind of memory, there are chances there is some memory leak in your code. I know what you're thinking. You might be wondering, memory leak in Python? That is impossible. And I am with you. If you're working with core Python, that is impossible. But when many of the libraries you are using are built with C Python or anything else, there are chances there is some kind of memory leak happening under the hood, which is not in your hands. So to solve that problem, Celery provides two thresholds: max memory per child and max tasks per child. So with the help of these commands, you can set thresholds either on number of tasks executed by the process or the amount of memory being used by the process. And when any of the thresholds is reached, it rotates the process and clears out stagnant memory. So when you're running something in production, you should always have the capability to keep an eye on it. And Flower works really well with just running one command. You can set up a full-fledged monitoring tool for your Celery setup. So it gives you capabilities like purging queues, view acknowledgement rates, view and modify queue worker instances, view scheduled tasks. It has an HTTP API for almost every data point so that you can integrate it in your own monitoring dashboards as well. And also you can use those endpoints to configure alerts so that you know when your system is going down beforehand. And if you are using RabbitMQ as your broker and you're more comfortable with RabbitMQ instead of Flower, then you can use RabbitMQ admin panel to monitor your system at the broker level itself. So it also gives features such as purging, deleting, and monitoring queues. So to conclude, in this talk, we understood why pipelines are better, how to tune your Celery config to get maximum performance, uh, how to add your setup, how to make your setup resilient or self-healing, uh, how to do what to do when unknown things are hogging up on memory resources, and how to keep an eye on your system. So if we follow all these steps while building our system, we will be facing a lot less issues. Our system will be production ready, and we will sleep soundly. So that is it from me. If you have any questions or feedback, I'd be happy to work on it. Also, if you didn't like the presentation, I'm also open to take virtual tomatoes. So yeah, that is it from me. Over to you, Sangarshanan.
Hey, thank you for that talk. It was amazing. I don't think you would be getting any tomatoes though. And
I
so you
hope so.
can, yeah, you would, I'm sure. I don't think we have any questions on YouTube. I think it's mostly because it's like an odd time for people around the world. So like
I understand
either
that.
most of them are sleeping or they're like yeah. So also you can actually hang around on Discord or on the YouTube chat. Someone might pop up a question. So I think he'll be hanging out there if you guys want to ask any questions regarding to celery, task use, anything else you saw his talk, you can just ask it out. Thank you so much for your talk. It was amazing.
All right. Hey, thank you. Thank you for having me. Bye bye.
All right. So think our next talk is scheduled to start at 12. So I think we have around 8 minutes left before the start of our second talk. So I think now it's the time to play a sponsor video, I guess. Let me just find it and play it for you guys. Hey everyone, hope y'all can hear me now. Really sorry for that. Let me just remove the banner. Alright, awesome. So our next speaker on par is Gajendra Deshpande. He's going to give us a talk about using Python for investigate digital crimes. And he's giving us a recorded talk. So I'm just going to share that.
Hello everyone, my name is Gajendra Deshpande and I am working as assistant professor at KLS Cooked Institute of Technology, India. Today I will be presenting a talk on investigating digital crimes using Python. So in today's talk, I am going to discuss about introduction to digital crimes, digital forensics, then the process of investigation, collection of evidence, investigation of acquisition media using the PyScreenshot module, investigation of emails, investigation of embedded metadata, then finally the conclusion. Now let us look at some statistics related to cybercrime. So the Internet Crime Report for 2019 released by USA's Internet Crime Complaint Center IC3 of Federal Bureau of Investigation has revealed top 4 countries are victims of internet crimes. So USA has more than 60,000, then UK more than 93,000, Canada more than 33,000, and India more than 27,000 crimes have been reported. Now note here that these are just the reported numbers and unreported numbers are much higher. According to RSA report of 2015, mobile transactions are rapidly growing and cyber criminals are migrating to less protected soft channels. So your gadgets, smartphones, mobile phones are treated as soft channels because many people are not aware of various security settings in those devices. According to report by Norton in 2015, an estimated 113 million Indians lost about rupees 16,558 on an average to cybercrime. So that's roughly around $250. According to an article published by Indian Express on 19th November 2016, over 55% millennials in India are hit by the cybercrime. So millennials are those people who are born between 1995 and 2010. So they are more gadget friendly people. They use gadgets very heavily. So obviously they are targets of cybercrime. Then a recent study by Checkpoint Research has recorded over 150,000 cyber attacks every week during COVID-19 pandemic. So there has been an increase of 30% in cyber attacks compared to previous weeks. So the reason here is that many people have lost their jobs and many people have also experienced the pay cuts. So pay cuts is the one of the many reasons for employees' unhappiness, and people who have lost the jobs, they find it easy to commit cybercrime and earn money. Let's first define forensic science, then we will define what is digital forensics. So forensic science is the use of scientific methods or expertise to investigate crimes or examine evidence that might be presented in a court of law. Cyber forensics is investigation of various crimes happening in the cyberspace. So examples of cyber attacks include phishing, ransomware, fake news, fake medicine, extortion, and insider frauds. So during COVID-19 pandemic, you might have observed that many fake news have been circulated during with respect to the cure and vaccines related to COVID-19. And also, one more major problem is the insider frauds. So insiders are those people who are within the organization. They have access to the confidential information and they use this information against the organization. According to Digital Forensics Research Workshop, that is DFRWS. The digital forensics can be defined as the use of scientifically derived and proven method toward the preservation, collection, validation, identification, analysis, interpretation, documentation, and presentation of digital evidence derived from digital sources for the purpose of facilitating or furthering the reconstruction of events found to be criminal or helping to anticipate unauthorized actions shown to be disruptive to planned operations. So if you look at the definitions here, there are multiple aspects covered. The important aspect is that it covers the steps in digital forensics investigation process. Then it also says that the importance of reconstruction of events in creating the crime scene and finding the evidence, and finally it also emphasizes on the presentation of the evidence in the court of law. So these are the 6 steps which every digital forensics investigator needs to follow, which you have already seen in the definition. So first one is identification, then collection, validation, examination, preservation, and presentation. So let us look at these steps in detail. So the first step is the identification. Whenever a crime happens, investigating officer may get a call, and when investigating officer visits the crime scene, he needs to first identify the objects which he needs to seize. So he can seize anything related to the crime or whatever he feels that one's object may have the evidence. So with respect to digital crime, he needs to acquire and seize relevant devices, relevant objects. Say for example, laptops, mobile phones, and various devices such as CD drives, DVD drives, USB pen drives, and so on. The next step is collection. So once the different objects have been identified, the important step is to collect the evidence. Now, whenever the investigating officer is collecting the evidence, he needs to first collect the most volatile evidence first. Then he needs to collect the least volatile evidence. So there is an order defined in the standard procedure in case of live forensics, which evidence needs to be collected first. So one example what we can take is the investigating officer may collect the evidence from the RAM first. Then he can collect the data from the hard disk, because if you turn off the system, then it will change the system status, and there's a possibility of losing the information or evidence. Okay, so, and one more important point the investigating officer keep in mind is that he needs to note down the status of the system. If the system is on, he should not turn off it. If system is off, he should not turn on it, because turning on and turning off the system will change the system status. It will alter few system files, and when this modification happens, there is a possibility of losing the evidence. So he needs to note down the system status, and if the system is on, he needs to perform the live forensics. The next is validation. So what we do is we perform forensic process on the copy of the data. So there will be original data and there will be copy of the data. So he needs to compute the hash on both the data and verify that the copy and the original data are same. If there is a difference, then it means that the hash, if the hash is modified, then it's a clear indication that the evidence has been modified or data has been modified, or there has been some tampering. The next is the examination. So this is very, very important step with respect to forensic activities. So here various tools can be used, maybe commercial tools or open source tools, to extract the information from various sources and analyze it. So your information can be extracted from the log files, can be extracted from the system files and various other sources. So you can write a code to examine the evidence, or you can use the ready-made tools. The next is the preservation. Now note here that preserving evidence is very, very important. So when you take into custody, when the investigating officer seizes any device, maybe hard disk or cables, he needs to keep it in appropriate anti-static bags, or he needs to keep it in Faraday bags, which will actually avoid the tampering of those devices. And the data needs to be stored in appropriate room temperature and in a locker. So data needs to be protected from unauthorized access by people, and also from the environment. So environment may also play some role in altering the evidence. Okay. So it needs to be stored at appropriate place with appropriate protection in a locker. Then final step is the presentation. So if you have followed the standard procedure in previous all these 5 steps, then only it can be presented in the court of law and court will accept it as the evidence. But if there is a lapse in following the standard procedure, then court will not accept the evidence. So it is very, very important to follow the standard procedure led by the governments or law enforcement agencies, so that the evidence can be accepted in the court. Now let us look at some Python packages related to digital forensic activities. So first one is the PyScreenshot, which is used to take the screenshot of an entire screen or a part of a screen. Then QPRE, it is encode and decode MIME coded printable data. So MIME stands for multipurpose internet mail extensions. So using MIME, you can send and receive multimedia messages using the email. The next is the mutagen. So it's a Python module to handle audio metadata. Then PyPDF2, it's a Python library which is built as PDF toolkit. Then next is PE file. So PE file stands for portable executable file. It's a multi-platform Python module to parse and work with portable executable files. And these are Windows operating system related files. Now the first package we will discuss is the PyScreenshot. So it tries to allow to take screenshots without installing third-party libraries. It is cross-platform, but mainly useful for Linux-based distributions. It is available as a wrapper, so it can capture either whole desktop or an area. So it supports both Python 2.7 and Python 3 plus versions. So the drawback is interactivity is not supported and mouse pointer is not visible. Performance is not a target for this library because in forensic activities, it is important to find the evidence and not the performance. But you can make some settings and achieve the performance up to certain extent. So that we will discuss in next slide. You can install PyScreenshot using Python 3 -m pip install below PyScreenshot command. So here we're installing PyScreenshot as a wrapper for below library. So there are many other libraries. You can install PyScreenshot as a wrapper over your favorite library. Now on the screen, you are seeing the screenshot, which actually takes the screenshot of the entire screen. So in the first step, we're importing PyScreenshot as the image grab. Then we are using grab method. And once the grab method is executed, it needs to be saved in a image file. So we are saving it in fullscreen.png file. Now in this screen, you are seeing the source code, which actually takes the screenshot of a area of a screen. So it starts from x1y1 to x2y2. So you can see here in a grab method, you are passing the parameter b box, and equal to you are specifying x1, y1 and x2, y2 parameters. So it will take a screenshot starting from x1, y1 to x2, y2. Now this is about the performance of PyScreenshot module on various libraries. So you can see here that per call it is showing some milliseconds. So these are the time for taking 10 screenshots. Okay, now you can set child process is equal to 0, and when you set child process is equal to 0, you can observe that some packages are taking less time. So it will help you to select the appropriate library if you are worrying about the performance. Okay, so you can make some more settings. For example, set backend as a scrot, and maybe also you can set backend as MSS and child process as false. So you can make these settings to achieve better performance. Okay, so the next concept is email investigation. So in email investigation, we can see here that many people receive spoofed emails, and it is very easy to identify actually the spoofed email. Okay, so one important thing here is you can observe the from address, and you can also place the mouse cursor over the links which you receive in your fake emails or spoofed emails. So when you place a mouse cursor over the links, observe the status bar. Don't click on it, just observe the status bar. And when you observe it in status bar, it is showing the exact URL. And you can notice here that it is not from the original source. And if you are not using the generic email IDs like Gmail, Hotmail, or Yahoo, if you are using your organizational emails, then it is possible that you can configure SPF, that is Sender Policy Framework, and other things to avoid spoofing of emails. So this is a spoofed email you can see on my screen. It says that there is a billing information from Netflix, but I don't have any account in Netflix. And similarly, this is some email related to settling of some unclaimed sum of $15 million. So again, it's clearly a fake email. So you need to just ignore these messages. Now, the main goal of email investigation is that to identify the main criminal, then to collect the necessary evidences, then to present the findings and to build the case. Then challenges in email forensics are the fake emails, spoofing, then anonymous re-emailing. So fake emails, we know that any people can directly send these emails, and in spoofing, it's actually sent as the original email, but actually you are not receiving the email from the legitimate source or from an authorized person. Although it looks like that you are receiving the email from the legitimate source, but in reality it is not. Then in anonymous re-emailing, it's a problem on the server side, so it needs to be rectified at the server. Now, techniques used in email investigation are header analysis, then the server investigation, then network device investigation. Now you can see some part of the code here. So actually what we are doing here is we are accessing the headers, body content, attachment, and other payload information of the email. So once we extract this information, we can do further analysis. Now this part of the code, what it does is it extracts the message body content by using get payload method, and it also checks the content MIME type so that it can handle the storage of the email properly. Now note here that in MIME what happens, MIME stands for multipurpose internet mail extensions, and it allows us to send or receive multimedia email messages. So when we say multimedia email messages, it may be images, it may be audio or video file, or some other content. So based on the goal of email investigation, we can either ignore some file types. So when we ignore some file types, or when we don't consider some file types, we can actually save a lot of space and also time. Then this is a code snippet which actually extracts the attachments from the emails. So all this source code you can find on tutorialspoint.com. So the link has been already shared in some of the slides. Now this is a code which is used to extract the message body of the email. The next is metadata forensics. Now Mutagen is the Python module to handle the audio metadata. It supports various file formats including MP3, OGG, and so on. Again, it's a pure Python library, so no dependencies outside the Python standard library. So it works with Python 3.6 plus versions. So you can install it using Python 3-m pip install mutagen command. So the screenshot, what you're seeing on the screen, what it is doing here is that it takes any audio file as the input and guesses its type and returns the file type instance or none. Okay, so for example, here it is taking awk file as the input and it is returning the information of awk file, saying that it is awk verbis type and the length and also the bits per second. Now on this screen, you are seeing two snippets. The first part says that the file function, it takes again any audio file, guesses its type and returns the file type or none. So it is almost same as the previous source code, but here in this case, it is dealing with the flag type. Now on the right hand side, it is getting the information of a MP3 file. So it is getting the type and saying that it's MP3 file, its length and its bitrate. The next is the PyPDF2 module, so which is actually used to extract the information from PDF documents. So again, it's a pure Python library, so no need of any other dependent libraries. So it is capable of extracting document information, that is metadata like title, author, and so on, splitting the documents page by page, merging the documents page by page, cropping the pages, then merging multiple pages into single page, encrypting and decrypting PDF files. It is also a useful tool for websites that manage or manipulate PDFs. The next is PE file, that is portable executable file. Again, it's a multi-platform Python module to parse and work with portable executable files. Most of the information contained in the PE file headers is accessible, as well as all sections, details, and data. The structures defined in the Windows header files will be accessible as attributes in PE instance. The naming of fields or attributes will try to adhere to the naming scheme of those headers. So only shortcuts added for convenience will depart from that convention. So PE file requires some basic understanding of the layout of a PE file. So with it, it is possible to explore nearly every single feature of PE file format. Now, some of the tasks that are possible with PE file are inspecting headers, analyzing sections data, retrieving embedded data, reading strings from resources, warnings from suspicious and malformed values, overwriting fields, packer detection with PID signatures, and PID signature generation. So the conclusion is that it is very important to follow the standard procedure laid by law enforcement agencies during the investigation process. Otherwise, evidence will not be admissible in the court. Then there are many open source as well as commercial tools for digital forensics, say for example NCase and so on. And learning to develop your own tool is always advantageous, because we can't wait for a particular feature to be included in the standard tool. So if a particular feature is not present in the standard tool, then you can directly write a small piece of code and achieve the goal. So that's why it is very important to learn and explore the possibilities of languages like Python to write your own tool with respect to forensics, or any other tool for that matter. Many tools written in Python are pure Python implementations, so you need not have to depend on any other tools. And one more point I would like to add here is that once the information is extracted, you can now use many artificial intelligence algorithms or machine learning techniques to analyze the information and generate the evidence. Thank you for attending my talk. So I'm ready to take questions if there are any. Thank you.
Oh, hey everyone, welcome back. Thank you for that amazing talk, Gajendra Deshpande. I think he has something. I think he has another talk to attend to. But he will be around on YouTube chat if you have any questions, or you could also ping him on Discord channel if you have any questions that you need answering. This is an interesting talk. Thank you so much. I think now we have around 4 minutes left for our next talk. Our next talk is by Nithish Raghunandanan. He's an engineer who loves to build products that solve real world problems in a short span of time. Don't we all? So I'm going to just welcome him onto stage. Oh, hey Nithish, how are you?
Hi, I'm good. How are you?
We hear some static noise from your end. Do you know, is it something that you can solve?
Oh, let me just check.
Sure.
Okay, is it better now?
No, I think we can still hear it.
Okay, let me just...
It's this weird ringing kind of noise. Can anyone else confirm? Oh, I think now it's fine. It's fine now, right? Awesome, perfect. Oh, but we can't hear you now too. I think you muted yourself. Hey, I think you're on mute, so we can't hear you.
Now it's better?
Yeah,
Okay.
now it's awesome. Perfect. Thank you so much. I guess we have 3 minutes left, so I guess we can try to make some conversations.
Yeah.
Like, have you checked out any of the talks that happened during the course of 24 hours of Pyjamas?
Yes, yeah, I checked out a few talks, especially like the ones yesterday. Yeah. And some of them were really cool.
Yeah, which ones do you think were like the best for you? Like, which ones did you enjoy the most?
The one from Mark was really good. The mistakes in Python.
Yeah, he always
that-
gives amazing talks.
Yeah. Yeah, that was good. Yeah. What about you? Which talks do you like?
Oh yeah, I like that talk too. It was really, really amazing. I was really looking forward to it too. His talks are always awesome. And also after that, the panel session was really cool too, where they talked about what devils do and stuff. That was really awesome as well. Cool. Oh, I think we just spent 1 minute. So we have 2 minutes more.
Yeah.
Cool. I think I'm just going to read out cat names.
Cat names.
All right. So what would you name your cat? If you had a cat, what would you name it?
I used to have a cat, so we used to call it Chiku. Yeah.
Okay.
Yeah.
From the fruit, is it?
Yeah, I mean, not exactly the fruit, but yeah. I mean, it was just like a pet name.
Oh yeah, please. I think we have one of our standby volunteers who has a cat himself.
No, I don't have a cat. I have a
Oh,
dog,
you have a dog. Awesome.
which is not my dog. So
Oh.
we call him Mr. Spock.
Mr. Spock.
Yeah, like because his ears look like this Spock character. But I think a good name for a cat would be Simba.
Simba. That would be a
Wait,
good name
is
for a
it-
pet lion though.
Oh, I wish I had a pet lion, but that would be animal cruelty.
For you or for the lion?
Cool. So could you tell us a little bit about your talk, Nithish, before we begin? Creating
Yeah,
data
sure.
apps.
Yeah, so basically I came across this cool open source library Streamlit last year, and I just wanted to play around with it, and this was like an excuse to do that. So I just submitted a proposal, and tried to build something small, and then share my experiences. Yeah, that's this whole talk about. So it's going to be about how you can build data apps using Python. Yeah.
Oh, that's
Alright,
awesome. I think we just reached time right now.
Oh, yeah.
Yeah.
I was just about
Thank
to
you so
ask.
much, Jacob, for jumping in and saving us. So we're creating data apps with Python. We have Nithish and we have your screen right now. So please get started. All the best. It's the last talk of Pyjamas, so let's finish it off in style. So yeah.
Yeah.
Take it away.
See you
Yeah.
guys.
Thanks. See you. Okay. Hi everyone, so I'm Nithish, and in this talk, I'm going to present about how you can build data apps using Python and without using any of the external dependencies like JavaScript libraries or CSS or HTML. And okay, let's get started. So a little bit about myself. So my background is mostly data engineering. So I like to build prototypes, go to a lot of hackathons, build things over a weekend, and I mostly like to work with Python. I also organize the PyData Munich chapter. I'm based in Munich, so I work in an innovation lab of an e-commerce company there. And I like to travel, and you will also see a bit of it in the presentation. And yeah, you can also find me on most platforms with the Nithish tag. Okay, so that's about myself. So what you might be wondering, what is Streamlit? So Streamlit, this is mostly taken from their website. So it allows you to turn data scripts into web apps. What does that mean? So you have your normal pandas or Python code, which you can make it, make it interactive by adding a few components from Streamlit. And you don't need any front-end experience, and it's also really easy to deploy. For example, this is an example shown on their website where they do some real-time computer vision, which is completely interactive, and you can see the code on their GitHub page. And so if you look at it, so internally what they do is they convert all these components from Streamlit into React components, but you don't need to worry about that because all this is hidden away from you. And it has like compatibility with most major frameworks or libraries like scikit-learn or Keras or PyTorch, and also all these visualization libraries like Altair or Bokeh or Plotly, even Matplotlib and Vega or LaTeX. So in this talk, I would like to cover like two use cases. I mean, I'm not an expert on Streamlit, but these are some things which I just tried like to see if I can do something with Streamlit. So I wanted to build like an interface for machine learning and also visualize some data. So more about the first problem that I'm trying to solve. So I'm trying to build some interface that helps you to visualize the machine learning outputs easily. So normally what I used to do before Streamlit was I would build my model using Jupyter Notebook and then write a small wrapper API in Flask or Fast API. And then to deploy this or like to make this useful, I would also build a small front end in HTML or JavaScript, HTML using JavaScript and CSS. In some simple things like Bootstrap. I mean, what I experienced was this takes like about a day to get this whole thing done. And at the end, because my UI skills are not the best, I always have problems that it's not the most friendly to use. And when you want to run this in production, you definitely need a designer and a front-end engineer who has to spend some time with it. Whereas in the Streamlit workflow, you build a model like you do normally in your Jupyter notebooks or wherever, and then you add the Streamlit components for UI. So like input fields or sliders or things like that. And in the end, you can deploy this as a web app. What do I mean by it? To show you an example, what I did was I just took like the public ImageNet image classification model, and I built a small interface for it using Streamlit. And okay, let me just show you the demo. Okay, so this is like something which I'm running on my local machine without doing anything on the network. So here you have like a input field where you can select which network to use from the ImageNet. and you can also upload an image that you want to classify. So let me just upload some image. Okay, let's see. Okay, maybe this one. And what this is right now doing is, since I changed one component, it would run this file and try to give you the output. So this is all coming from, the interface is coming from Streamlit. So it ran this file dog, it uploaded this file, and then with this model, try to get the top 5 predictions and gives you the confidence of it, and also gives you the top prediction. And you can also change it. So if I change the model here, it would change the output. So you can see that now it has changed to 51.83% with Labrador Retriever. And similarly, you can see any other model. And you can see that the script is running in the background whenever any of these inputs change. Yeah, and here you can see that this model is probably the best because it's, the confidence is higher. Yeah, and I can also have a small demo of the code. So what this is doing is, it's right now getting the code from GitHub and then just showing it as a markdown file. And most of this is like standard image recognition for ImageNet, which is taken, which I have adapted from the PyImage search demo. And so here you just need to import Streamlit as ST, and then you can, all these lines that start with ST are the ones which are Streamlit components. So for example, here you have a title, you have a sidebar, header, for example, and this is like the select box, which you use to select these models. And here you have a file uploader, and you can also restrict the sizes and formats supported. And this is like the toggle button for the showing code. And all this internal logic is basically the pre-processing and the model processing. So like you convert the image and do some pre-processing, like converting to the right size, and then you predict it using the model, and you get like a dictionary which you convert into a pandas data frame, and you can just output it as like st.data frame. Yeah, and another interesting thing which I would like to point out is this Streamlit caching. So what this does is, if you, for example, right now, if you toggle this file won't be fetched again from GitHub. So this function is executed more than once, only if either the input changes or the function changes. So there is an internal memory store where it keeps track of all the inputs and the corresponding output. If they don't change, the file is loaded instantly. And yeah, so it's right now taking a bit of time, but normally it's quite fast. Always the pain with real-time demos. But anyways, you get the point that, yeah, this is one of the main components that you can use to improve your performance of your Streamlit apps. Okay. And if you look at the code, the code is quite similar to what you do for a command line parser, but you get like much fancier input or fancier interface without much of effort. And most of the code components require just like 3 or 4 lines of Streamlit code. Okay, so coming to my second use case. Normally you typically have like a lot of data that you generate, like reports or some visualizations that you showcase to other people. And there are a lot of different ways to do it. Like you can do it in Jupyter notebooks, do presentations, you can write scripts, you can build your own custom code, or you can also do reporting in software like Tableau or Power BI or Looker or things like that. But what if you could also develop web apps for it? And I'll just tell you like a bit of what I used to do before I switched to Streamlit. So I was using Jupyter notebooks for my visualization. It is great for experimentation, like all the graphs and everything. You can do write stories using the data. You can convey some stories. But most of the time, the issue I face is like, how do I share it with someone? They might not have their corresponding interfaces or like the libraries installed, or there is some issue with like the code flow. I mean, there are lots of issues with Jupyter notebooks in terms of sharing with others, especially if you want to run it interactively. And there's also a really cool talk from Joel Cruz from the Jupyter Con last week about why he doesn't like notebooks, and it's a really good talk. Okay, so with that in mind, so I wanted to build something which would enable me to visualize my Google Maps data. Like, I really like the timeline, what they do. So you store all your data with Google, which I do. And then you can go to your timeline on Google Maps and see where all you have been and all those kind of information. Google also offers you like an interface where you can download these data points for you. And there are also third-party visualizers where you can see like histograms of your location history. So I'm trying to like see if I can somehow recreate it or with Streamlit. That was my my whole hypothesis. And what I observed was there are some issues with the data that Google provides you. Like, it's not in the standards that you expect, but you can easily convert them to the right standards. But one major issue which I faced was that there is no information about the places or apart from the GPS coordinates. And it's pretty hard to get this data for like a huge data set like that I had. And to compensate for this, I tried to add some background information. So Flickr, the open image sharing platform, has like an open API, which allows you to get images based on GPS coordinates. So that's what I'm trying to use here so that I can add some images. So maybe I remember the place better. And also the standard things like histograms or heat maps. And so this is how it like kind of looks like. So you have like the visualization, which is provided by Streamlit, and you also have like heat maps and some images and histograms. Let me just show you the app. Okay, so let me just refresh the app. But this is also running completely on my local machine. And so here you can see that I'm getting data from 2013 to 2020, and it's around 800K data points. And Streamlit is loading this data in a map. And for this, I didn't have to do anything. I just loaded the data frame and showed. And if the data frame has a latitude and longitude data, you can also, it automatically has this option to visualize it. And you can also zoom in, zoom out, do all kinds of things. And it's quite responsive, I would say. And to make this interactive, you can go filter the data based on time frames. So like you can see what happened in 2018 and 2020, and the map is automatically centered based on the data. So internally, Streamlit uses PyDeck for this graph, and you can also get the tiles from Mapbox, which I use here. Yeah, and so you can also filter based on any kinds of, yeah, so you can see that 2019, 2020, it's a much smaller radius than before. And you can also see like histograms of when these data points were collected. So for example, 2019, so this is only 2 months of 2019, so it's probably lesser data. And so if you increase it, you can see how many data points were collected per year. It takes a bit of time because of the data set. Yeah, so you can see that I was probably visiting more places in 2016 than other years. And you can also see similar information by months. I mean, so you can see that probably summer is the time when I travel more, and you can also see like what hours I was more active. So like you can see that I'm not too much of a late night person. And yeah, so that was histograms. And you can also do similarly heat maps. So heat maps takes a bit of time. Yeah. But you get the feedback that it's still running. And whenever you change any of these elements, the whole data performance. Okay, it's still running. Okay, maybe I'll just stop it and run it again, or change the data points to much smaller. So now, maybe just refresh the app. Yeah, always the problems with the live demo that you might face some issues which you don't see before. So let's get to a smaller data set. Okay, so this is only 100K data points. And now you should see the heat map. Okay, or I can also just show the images. So here, okay, let's see if it loads in a minute. Okay, the heat map. Heat map is like loaded and you can basically go around it. And this heat map is actually produced using Folium, which Streamlit doesn't support out of the box. But there are like community plugins which you can use to integrate a Folium with Streamlit. And you also get some random images based on the locations, and you can also increase it or decrease it based on how you like. And these images, I haven't put in a lot of logic, so I'm just getting some random image from this filtered data set and just showing it. Okay, let me also just show you the code that is used to create all this. So this is a bit more involved than the last one, but still it's not a lot of data, not a lot of code. Maybe I should disable the heat map because it's the most intensive operation. Yeah, so here you can see, it's similar to the last one, all the imports. And you can set the page config, which sets all these titles and how you want this page to be loaded. And I'm doing some basic cleaning, like renaming the columns so that you have much better, so that Streamlit can detect it out of the box. And this is the whole API logic where I get some random image based on the GPS coordinates that I get from the data. And so here is the whole slider logic. So you need to have the minimum and maximum for the timestamps. And you have this whole, so this is the whole mapping information. So if you just do streamlit.map and provide it a data frame with latitude and longitude, it works out of the box. And the histograms, they are matplotlib plots. And what else? This is the Folium heat map that I mentioned. And yeah, this is like coming from the community component. And yeah, the images, to load images, you just provided it a list of URLs and it can do it. Okay, since I'm running a bit late on time, I'll just go back to the presentation. So you might be wondering, are there alternatives? Yes, there are alternatives. So there are options like Vola, which focuses more on the Jupyter Notebook side, how to do interactive stuff on Jupyter Notebooks, the classics like Bokeh or Plotly or Panel. And I would say if you are comfortable with one of these existing systems, there is not a lot to move out of, except maybe the deployment. So yeah, but it's a matter of personal taste. So most of them offer kind of similar features. Uh, to conclude, what are some of the advantages and disadvantages with Streamlit? So Streamlit offers like the super interactive and customizable code. So you can write whatever visualization that you want and make it interactive. And the deployment is quite easy. Like you can just run this file on a server and open the port, or you can also package it in Docker and run it. And it also has a really active community. The forum is quite active, and also people are responding to questions. I mean, coming to the some of the drawbacks. So they have launched a beta version of Streamlit sharing, which allows you to share your Streamlit components or Streamlit dashboards with the world. I mean, I tried to load this machine learning model on it, but I mean, I faced some issues. I believe it's basically due to the deep learning frameworks that I use. Another issue is the authentication. So these authentication, there is no built-in authentication in Streamlit. So they plan to introduce this in the paid version, but there are workarounds for it. Like you can use your CDN for it, or you can also do a reverse proxy, or you can also put like a password field based on which you authenticate and load the rest of the dashboard. And I've also added like the GitHub repos for these visualization. And there are also some Streamlit, more examples in their Streamlit gallery. And yeah, if you have some questions, you can always reach out to me. Yeah, with that, I'm done. And if you have some questions, I'll try to answer them.
Hey, awesome. Thank you so much for the talk. It was really, really amazing. We always try to explore, creating interactive dashboards for people who are not rather comfortable with code, and all these uh, 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 amazing tools like, the ones you mentioned, Dash, Vola, Streamlit. They make it really easy for us to, share our code and stuff. So it was really awesome.
Yeah.
And so in the amount of time it takes, right, to set things up, like, which do you think is easier to just quickly set up and just share with people? Is it like Vola, Dash, or Streamlit? Or something
I
else?
mean, to be honest, I haven't used the other tools too much. So I've just tried Vola. I mean, I felt like Streamlit was much faster. So for example, this machine learning thing, it took me just 1 or 2 hours to find the right components and then just put things together. And then it was running from like the very first hour. So I didn't have to do much.
Okay, awesome. I'm just checking if you have any questions that we have, but actually I have a lot of questions, so I'll just continue.
Yeah.
Also, I had another question, like on the similar
Yeah.
lines, far from effort, what about the learning curve? If you want to start building these dashboards or these stuff, right? Like, which do you think is just easier to just quickly start building, rather the effort on the learning curve side, which is easier to learn and just quickly do stuff?
I personally found Streamlit to be the easiest to get started with, because yeah, I'm not someone with a lot of experience in UI or visualization. So I found Streamlit really fast. Like their examples are quite comprehensive. Their documentation is really good. So you can find really good examples that can help you get started really fast.
Awesome. You don't seem to compromise Streamlit, and I like that very much. You're sticking to your talk, you're sticking to your framework, and that's awesome. I will be sure to check out Streamlit, and I'm sure people will do too. And you can actually check out the YouTube chat or on Discord if people might have any questions, and you can, hang
Yeah.
down. I think you are our last talk of the conference, so congratulations. You win nothing.
Yeah, thanks.
But, thank you very much for giving the talk.
Yeah. Yeah, thanks.
And also, yeah, thank you. Also, I would like to welcome, the people who want to close the program on stage. We have Les, we have Chuck, we have Jacob, and we have Shivangi. And actually want to take a moment to thank actually Chuck and Les, because they have actually spent sleepless days and nights trying to make this conference, awesome for each and every one of us, and that's really commendable from them. And yeah, I think they should get some real good sleep tonight. And I just wanted to take a moment to thank them for organizing the coziest conference that has ever happened. So thank you very much. So should I just add you guys onto the stream? I think we are almost done, right?
Good morning. Hello there. Good morning. I've just came back from a nap, so I feel like I just
That's awesome.
resuscitated. Yes, I came back from the bed. That's it. How was everything around here? Did you have fun?
Yeah, we had a lot of fun. It was awesome.
Good. Cool. So we have a few more people that I'd like to call as well to stage to say goodbye. I also have a presentation, but I would like to get everyone together now. So Jacob and Shivangi, everyone that would like to come over to stage, please do. Chuck, if you wanna join us as well. I saw Martin as well, kinda coming in, and I don't know if he's gonna join or not. Let's see. But well, first of all, I would like to say thank you. I would like to say thank you to everyone. First of all, our volunteers, because this would not be possible without you. Thank you. I would like to also to say thank you to all our attendees all over the world. We are so happy. Everyone was able to enjoy it. Everyone was able to join. And well, we didn't have that many big accidents, so that was good. The demo gods have also been very good to us. So although it was a 24-hour conference, in my opinion, everything went pretty smoothly. So thank you for everyone that joined us for the training sessions. Thank you for the preparation, because it takes a lot of work, but it was really cool.
Yeah, I can't wait for next year, 4th December, fingers crossed, or whatever weekend it is.
Yeah, same here.
So I think Martin is fixing his camera, but yeah, how about we let Lace to give the closing presentation, and then after that we will come back on stage once again.
Sure.
Perfect. Now, I would like also to say to everyone that I have no idea what are those slides. So it's a karaoke slide. It's a thing that Chuck loves doing with people. Apparently, it's a tradition. So with no further ado, let's go and see how I can do this. Let's see. Cool. So, oops. Okay. I don't know what to. Try this again. I'm having technical problems. We have had absolutely no technical problems throughout the whole conference. Now I'm having technical issues. So bear with me. I need a minute.
Now we need to put this stunning GIF to a good use. So that's actually on purpose, I guess.
We need to put what? Sorry?
This technical difficulty GIF to a good use. So so that's why it's actually on purpose. We planned it. This is all under our control.
Perfect. I made it work. It's
Or
all
I
good.
can share it and then you just present while I'm driving. That's more
If you
fun.
want to do that,
Yes, let's do that. That's
it's gonna be
even more
even better
crazy.
because I have no idea what's in there anyway. So, good morning, Martin.
Good morning. The last minutes on my camera craps out, so I just connected a new one.
Yeah, we love technical difficulties. That's how.
You cannot imagine how much fun this is. Like getting the stream running. It's not as easy as people might think at home, because they think, "Oh, I've got a webcam, I can do this." Well, try it.
Right.
Well,
Okay. So, Lace, are you ready?
Yes.
Okay.
Okay.
Yes. Cool. So let's start this. So we are reaching the end of Pyjamas Conference 2020. Yes, I think that's the word of the day. Did you have fun? Because this was the goal. We do hope we all had fun. It was a lot of fun for us. And yes, so we started 23 hours and 29 minutes ago at 8 a.m. UTC yesterday. If it doesn't feel like 23 hours, to be honest, we had 24 hours of 24 hours of non-stop. We had a few breaks in the middle, content and talks, and loads of people participating, loads of really cool chat on the Discord, a really cool chat here as well. So if you want to tell me, for everyone that is in the comments, if you want to tell me what was your favorite moment, what was your favorite talk? Is it dun, 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 dun. Yes, the correct value of pi is 3. That was Mark showing us how to edit Dunder methods. Or dun, dun, dun. Oh, the panel discussion, the developer advocate session. Did you enjoy that? I had a lot of fun hosting that. Or dun, dun, dun. Yes, our pajama showroom. We were giving licenses, JetBrain licenses on that competition. Tade say in the comments that the best part of the conference was meeting all the friends along the way. We're so happy to hear that. So maybe your best moment was, yes, I just love that emoji so much. We had a very, very, very few technical difficulties, but we managed to get out of them very easily. So that counts. Yes, I think we got very, very, very close to 1,000 tickets at the end. Thank you again for everyone that, yes, I know. Our goal was not to get this big. Our goal was, thank you. Our goal was to get, but the maximum amount of people possible that enjoy Python and that can come and have some fun and enjoy some talks and throw some questions around. By the end of the day, it was just much better than we expected. Exactly, we had absolutely none COC complaints, which is great. Thank you very much for being such a great community. I love the emojis. And yes, so thank you again, because we would not have been anything without you all. So thank you again to the volunteers. Thank you again for the attendees. Thank you for everyone that could volunteer, like even the 5 minutes of the week or an hour on the week to help us put this together. And yes, thank you for a sponsor. Thank you, Microsoft. Again, it was awesome. Thank you very much, our Kashmir sponsor, and then our community partners as well. So thank you, Python Island, for all the support, and Python Discord as well. We're talking about good resources to learn Python throughout, and Python Discord was one of my most used tools when I was learning, and they're really, really cool run Discord server. And if you have Python questions, you should just go there. They're really, really, really nice people. And yes, thank you for everyone that organized as well, and thank you for everyone that volunteered. We're super happy to have you here. And well, I guess now it's Pyjamas 2021 that we should be thinking about. Yes. So if you do want a Pyjamas 2021, leave us a message on Twitter. We would love to maybe throw some polls and see what would you like to have in 2021. And also, if you'd like to volunteer, the preps for a conference like this start very early. So we started last February. So we're gonna take maybe a few weeks off. But if you do want to be part of the organization team, please just send them a message as well. And on Twitter, exactly. And we will be there all year long. We have a very cool communications team that is going to be running that. So please just send us messages, send us DM. We absolutely love interacting with you. And dun 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 dun, Chuck would like to come to stage to announce that with me, because well, it was a very cool campaign. Thank you for the slides. You are muted. I can't hear you.
Sorry, I wasn't using my mic. I was talking to thin air. Okay, fine. So yeah, I already know because I prepared the slides. So I think you're too busy to count the votes. So who do you think is? So which one is your favorite? Who do you think win this competition?
Well, I loved Tanya's pajamas. I thought they were really cool. I really like the Beast and the Princess and the Beast, I think, talk. And then the speaker, I completely forgot her name now. I'm so sorry. But she dressed up like on Karaga, she dressed up as a princess and she had like the paws and everything. I thought that was so cool. Yeah, there were a few good ones, to be honest.
So okay, so the most voted one is dun 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 dun. Can I have a drum roll? And we don't have the sound effect like the Europython did. Okay, well, okay. Yep.
Oh! Danny with the Kokoro, that's so awesome.
Yes, so Danny, if you're watching, maybe it's too early in the UK, but yeah, we will contact you for the prize. And the second prize goes to drum roll.
I got it.
Yes. Everybody love your leopard onesies.
Oh, well, thank you. I look more like a unicorn now. I got a change of clothing.
Yeah, but you already won, so that's fine. Okay, so
thank you for everyone that voted.
See you next year?
Yes, see you next year.
Peace out. Okay, so before we really peace out, please, everybody, please come on stage when anyone here in the backstage. So let's come here. Yeah, I don't know whether that's the maximum. I don't know how many people can be in all at once, but at least we have 6 now. So keep coming. Yeah, so I think that's it. And I don't have the sound effect for the round of applause, but it's really good. And yeah, it really can't happen without any one of you, including you who are watching. And I'm so glad that it's a success. Like when it started as a concept, I just think that is fun to do. And even like, you know, a few weeks before when we have the meeting, I was like, yeah, let's reach to 300 tickets. And we kind of like overshoot, and then we did like 3 times what I was expecting. So that's really good. And also the discussion on Discord is amazing. I really loved it. One last thing about the Discord, if you have any message conversation you want to keep, please make a copy for yourself, because we can't promise that we will keep the server alive forever because our COC team is off duty after, you know, in 1 minute, in how many minutes? In 10 minutes? Yeah. Or 20. I can't count now. Yeah. So there won't be any enforcement of COC moderation. And oh yes, please show some comments in the chat. Oh, that's amazing. So yeah, so keep the conversation, and if you want to keep connected with the Python community online, I would recommend joining the Python Discord. They have a really, really good community there. They have a proper structured, place there you can ask questions, you can get help, you can meet more Pythonisters. Yeah, so I think that's it. And I hope you really enjoyed it, just like we did. And yeah, like Lace just said, that if you are interested to know whether there will be another one, or you want to participate in the next one, then please follow us on Twitter and reach out to us. If we are organizing another one, obviously we would have a recruitment procedure that would announce on Twitter as well. So please follow us on Twitter. We are at Pyjamas Conf on Twitter, so you will find us. Yeah. Anything anyone want to add? Yeah, it's a silence. It's what a end with such a high note.
Yeah, I think you said it all. Thanks for the time you spent for all of this.
Yeah, thank you guys for spending so much time and making this amazing.
Yep.
Maybe can you hear?
And we learned so much, so next year will be much more fun.
Yeah.
Definitely.
It was a lot of fun anyhow. So again, thank you. We cannot say anything else but thank you to everyone that helped running, for all the hours, for all the sweat, for all the meetings, for everything. It was awesome.
Yeah.
Thank you.
And now we should all go and use the pajamas for the real purpose.
Yeah, that's correct. That's correct. So, okay, and I think I will play the countdown video to end it. That's more sounds like I will play the 3 minutes countdown, so everyone, you can, relax and now go to bed.
I have one last announcement.
Okay.
You forgot. I'm so sorry. So the people from Python Island asked me to tell everyone that we're looking for speakers. So if anyone that is on the YouTube or anyone that gave a talk that wants like a little bit more of Python community and would like to just send a message or anything like that, they're looking for speakers for the event next week. So yeah, that's it. Sorry. Now back to Pyjamas closing. Sorry.
Okay, so I would play this. I think everybody loves this music now. I will play this one last time, and yeah, hopefully see you next year. Peace out.
Bye.